changing, I can't stand it. My heart can't take this damage. In the way I feel, can't stand it. Baby, I don't understand this. You're changing, I can't stand it. My heart can't take this damage. In the way I feel, can't stand it. Baby, I don't understand this. You're changing, I can't stand it.
Hello students, very good morning. Hello Narayan. I welcome you all to this wonderful platform that is Vedantu, right? Especially this channel, Vedantu 8, 9, 10 Telugu. So myself Narayan Sir, right students? So manam ee roju human eye and the colorful world, right? So ee particular topic part 2 నేర్చుకుంటాం, right? So ఈ session అనేది so it is closely associated with the same topic, that is human eye and the colorful world, right? But especially part 2. All right, so I request all of you to get your notebooks quickly, a plain notebook and a pen. Just a second.
Baby, I don't understand this. You're changing, I can't stand it. My heart can't take this damage.
Yes, hi, hello, how are you all? Hello Dinesh Kumar. In exam, the number of questions that it keeps on varying, Sarala. I cannot tell you the exact number of questions that will be asked. What you should do is you have to keep practicing more and more questions. Adi helpful ga untundi. Hello Chini, hello Anaparti, hello Chapati, Amulya, Nandini, welcome to the session. Hello Tirsa, hello Dinesh Kumar. Okay, so I'm happy to see there are like so many people in the early morning. You all like woke up and you're like studying for your exams. When is your exam? When is your next upcoming exam? Hello Akshaya, welcome to the session. I know students, it is a little too difficult to wake up this early in the morning. Alarm mogin tarvata you will again want to sleep again, right? But still you'll wake up and then you'll attend the session. That is so nice. Great students. So let us quickly begin. So over here, manaki we have a prism that is gifted to a person. Okay, so Suresh ani oka person unnadu, right? So we also have Suresh in the chat. Oh great. All the very best for your exam, Tirsa. Suresh was gifted with a prism. Okay, he's given with a prism as a gift, right? So and a red laser light is also given along with that, right? So I only red. So instead of red laser light, he might have also be given with some green laser light or whatever color it is, right? So does color really matter? We will check. We will check if color really matters. Okay. So now ఇప్పుడు ఇతనికి ఒక రేజర్ లైట్ ఇచ్చాము, ఇంకొక ప్రిజం ఇచ్చాము. See prism. What is a prism? When I say prism, we are talking about a rectangular prism. A prism on the two-dimensional plane, it looks like a triangle, right? And on the three-dimensional plane, there is a rectangular base for it. Then go rectangular base untundi, right? And from every vertex of that particular base, you have lines like this, okay? And they all will meet at this common vertex, right? So now what are we doing is, ఇప్పుడు అతనికి ఇచ్చిన red laser light తోటి అతను he's like taking a light ray and he's hitting one of the sides of the prism ni ila hit చేస్తున్నాడు, right? So when it is hitting the light, now what do you expect what do you expect the path of light to be as? మనం already refraction of light in curved surfaces, refraction of light at different surfaces మనం చూసాము, right? So what was refraction of light? Refraction of light was nothing but it was dealing with the bending of light. Refraction light అనే కాన్సెప్ట్ అనేది బెండింగ్ ఆఫ్ లైట్ గురించి డీల్ చేసింది, రైట్? సో నార్మల్గా మనం రిఫ్లెక్షన్ ఆఫ్ లైట్ అనేది తెలుసు, రైట్? ఇట్ ఈస్ నథింగ్ బట్ ద బౌన్సింగ్ బ్యాక్ ఆఫ్ లైట్, రైట్? సో వెన్ లైట్ అనేది ఒక సింగిల్ స్ట్రైట్ లైన్ మీడియం, ఒక సింగిల్ మీడియంలో వెళ్ళినప్పుడు, ఒకవేళ లైట్ అనేది ఎయిర్లో మాత్రమే వెళ్ళింది, ఒకవేళ లైట్ అనేది గ్లాస్లో మాత్రమే వెళ్ళింది, ఒకవేళ లైట్ అనేది వాటర్లో మాత్రమే వెళ్ళింది, ఇన్ ఆల్ దోస్ కేసెస్ లైట్ అనేది స్ట్రైట్ లైన్ పాత్లో వెళ్తుంది, రైట్? కానీ ఎప్పుడెప్పుడైతే లైట్ అనేది వన్ మీడియం టు ఇంకొక మీడియంకు, ఫ్రమ్ వన్ మీడియం టు అనదర్ మీడియం, ఇఫ్ లైట్ ఈస్ గోయింగ్, రైట్? ఇన్ దాట్ కేస్ అకార్డింగ్ టు ఫర్మాట్స్ ప్రిన్సిపల్ ఆఫ్ లీస్ట్ టైమ్, సో లైట్ ఈజ్ ఇన్ అ హరీ స్టూడెంట్స్, లైట్ అనేది చాలా హరీలో ఉంది, రైట్? ఏ డైరెక్షన్లో అయితే మనం దాన్ని ఇన్సిడెంట్ చేస్తామో అదే డైరెక్షన్లో వెళ్ళిపోవాలి, తొందరగా వెళ్ళిపోవాలి, అదే డైరెక్షన్లో వెళ్ళి, సో ఇట్ వాంట్స్ టు గో ఇన్ దాట్ డెస్టినేషన్, రైట్? సో ఇన్ బిట్వీన్ ఒకవేళ మనం డిఫరెంట్ మీడియంని చేంజ్ చేసామనుకోండి, సో లైట్ అనేది షార్టెస్ట్ పాత్ తీసుకుంటుంది, ఆ డిఫరెంట్ మీడియంలో షార్టెస్ట్ పాత్ తీసుకొని మళ్ళీ ఆ మీడియం నుండి త్వరగా బయటకు వచ్చేసి మళ్ళీ ఇంతకుముందు ఏ డైరెక్షన్లో అయితే వెళ్ళిందో అదే డైరెక్షన్లో వెళ్ళిపోవడానికి ట్రై చేస్తుంది. అది దట్ ఈస్ ద నేచర్ ఆఫ్ లైట్, రైట్? జస్ట్ లైక్ హౌ వీ హ్యూమన్ బీయింగ్స్, మనం ఇలా జంప్ చేసినప్పుడు మనం ఎందుకు ఆల్ ద టైమ్ కిందికి మళ్ళీ ఎర్త్ పైకి వచ్చి కింద పడతాము, రైట్? ఇట్స్ బికాస్ ఆఫ్ గ్రావిటీ, రైట్? వీ నో ద రీజన్, రైట్? సో ఇన్ ద సిమిలర్ వే, సో ఈవెన్ లైట్ బిహేవ్స్ ఇన్ దాట్, in whatever nature, like with whatever nature it has already dealing with from the beginning, right? So different mediums have different absorption and re-emission rates. See, when light అనేది ఒక మీడియంలో వెళ్తున్నప్పుడు ఆ మీడియంలో there are some molecules, right? What these molecules will do is when light is coming through in this air, ఓకే, ఎయిర్లో మనం లైట్ ఇలా వెళ్తున్నప్పుడు, సో ఇక్కడ మనకు కొన్ని మాలిక్యూల్స్ ఉన్నాయి, కొన్ని ఆటమ్స్ ఉన్నాయి, రైట్? సో దిస్ లైట్ విల్ బి అబ్జార్బ్డ్ బై ద ఆటమ్స్ దట్ ఆర్ ప్రెసెంట్ ఇన్ దిస్ మీడియం, రైట్? అండ్ దెన్ దే విల్ బి రీఎమిటెడ్ బై దట్ మీడియం. ఆ రీఎమిటెడ్ లైట్ రే అనేది మళ్ళీ ఇంకొక ఆటమ్కి వెళ్ళి తగిలి అక్కడ కూడా అబ్జార్బ్ అవుతుంది, మళ్ళీ రీఎమిట్ అవుతుంది, మళ్ళీ ఇంకో దగ్గరికి వెళ్ళి అక్కడ అబ్జార్బ్ అవుతుంది, ఇంకా రీఎమిట్ అవుతుంది. ఇలా అబ్జార్ప్షన్ రీఎమిషన్ దిస్ విల్ కంటిన్యూ టు హ్యాపెన్, రైట్? నౌ because I told different mediums, right? So let me tell you, like this is medium 1, this is medium 2. Here there are different molecules and here there are different molecules. You see here maybe there are molecules are like much denser, right? So and because these two are different medium, obviously ikkada absorption and re-emission rate different untadi, endukante ఇది water and this is air, ikkada absorption and re-emission rate malli different untadi, right? So this absorption and re-emission rate ante, so in water light will be absorbed by the molecules and it will be re-emitted at a different rate, అంటే కొంచెం స్లోగా అబ్జార్బ్ ఇంకా రీఎమిట్ చేసినట్టుంది, రైట్? సో స్లోగా అబ్జార్ప్షన్ ఇంకా రీఎమిట్ చేసింది కాబట్టి ఈ లైట్ రే అనేది నెక్స్ట్ ఆటమ్కి పాస్ అవ్వడానికి కొంచెం టైం పడుతుంది, మళ్ళీ అక్కడ కూడా కొంచెం అబ్జర్వ్ అవుతుంది, రీఎమిట్ అవుతుంది, బట్ అబ్జార్ప్షన్ అండ్ రీఎమిషన్ రేట్ అనేది డిఫర్ అవుతుంది. ఎందుకంటే ఇది వాటర్, ఇనిషియల్ ఇట్ వాస్ ఎయిర్, రైట్? సిమిలర్ నౌ ఇట్ మైట్ బి కెరోసిన్, then it might be petrol, right? So this absorption and re-emission rate will keep changing from medium to medium. Because of that, speed of light will get reduced, right? So our light speed అనేది reduce అయిపోయింది కాబట్టి, లైట్ స్పీడ్ అనేది రెడ్యూస్ అయిపోయింది కాబట్టి అకార్డింగ్ టు ఫర్మాట్స్ ప్రిన్సిపల్ ఆఫ్ లీస్ట్ టైం, రైట్? సో ఈ మీడియంలో, ఇప్పుడు ఈ బ్లూ కలర్ మీడియంలో లైట్ స్పీడ్ అనేది రెడ్యూస్ అయిపోయింది, రైట్? సో రెడ్యూస్ అయిపోయినప్పుడు అకార్డింగ్ టు ఫర్మాట్స్ ప్రిన్సిపల్ ఆఫ్ లీస్ట్ టైం నాకు చాలా టైం పడుతుంది ఈ మీడియం నుండి వెళ్ళడానికి, రైట్? సో ఆ టైం పట్టకుండా, okay, in order to compensate that reduced speed, what light will do is it will try to bend, see ikkada manaki ee point dagara, let us say this is the normal, an imaginary line that passes perpendicularly to the surface, right? This is the angle of incidence. Now this is the angle of refraction, right? So this angle of refraction, as you see, this got reduced. Mana angle of refraction anedi angle of incidence kana takku undi. Yes students, can you see that? Yes. So when light is going from a rarer medium to a denser medium, light will bend towards the normal. The reason why it is bending we saw, right? Because of reduced speed, and light is in a hurry in order to compensate that, right? So light will quickly go in this medium and finally it will come out of the medium and it will go in the same initial path, right? So you can intuitively even you can understand. Chudandi, ఒకవేళ లైట్ ఇదే డైరెక్షన్ వెళ్ళిపోయింది అనుకోండి, ఈ లెంత్ ఎక్కువైపోతుంది. దిస్ బ్లాక్ కలర్ లెంత్ ఇస్ బిగ్ వెన్ కంపేర్డ్ టు దిస్ బ్లూ కలర్ లెంత్. ఓకే, ఒక మీడియంలో తక్కువ టైం స్పెండ్ చేస్తే ఇట్ విల్ బి ఈజియర్ ఫర్ దట్ లైట్ టు క్విక్లీ గో త్రూ దట్ మీడియం అండ్ కమ్ అవుట్ ఆఫ్ దట్ మీడియం, రైట్? సో నౌ ఓవర్ హియర్ ఇన్ దిస్ కేస్ మనకు ఒక ప్రిజం ఇచ్చారు. మనకు ఒక ప్రిజం ఇచ్చారు, రైట్? అండ్ ఫర్ దిస్ ప్రిజం we are now given with a red laser light. We are now given with a red laser light, right? So at this point, ఈ surface కి ఈ point దగ్గర let us draw a normal. This is an imaginary line. This is a normal, right? And the angle made by the incident light ray with the normal is what we call as the incident light ray, right? Now when light is going from a rarer medium to denser medium, we know that light will bend towards the normal like this, right? Now this is the angle of refraction, right? Similarly at this point, ఈ పాయింట్ దగ్గర కూడా మనకి ఇంకొక నార్మల్ ఉంటుంది, ఇలా ఉంటుంది, right? Now this light, it is coming from a denser medium into a rarer medium. ఒకవేళ లైట్ రే అనేది denser medium to rarer medium వెళ్తే ఏమవుతుందండి? yes, you can అన్నపర్తి ఏపీ వాళ్ళు కూడా వినొచ్చు, but the content will be a little more for you, okay? But still it is helpful for you. CBSE also can listen. The refracted light ray will bend away from the normal and the light ray will go like this. Okay, the only extra thing AP and CBSE students మీకు ఇక్కడ ఎక్స్పీరియన్స్ చేయడానికి ఉంటుందంటే ఏంటి అంటే డెరివేషన్స్. In Telangana board you have a lot of derivations to do. Okay, so here we have a red laser light. Okay, so ఇప్పుడు మనం రెడ్ లేజర్ లైట్ ని మనం ప్రిజమ్ కి ఇన్సిడెంట్ చేస్తే సో లైట్ రేస్ అనేవి ఇలా బెండ్ అవుతూ ఉంటాయి, రైట్? This is your red light. Angle made by that light with this normal is angle of incidence. The refracted light ray will go straight like this, and then this is how the light ray will again bend, right? And this is your emergent light ray, right? And this is the angle of emergence, right, students? And this is your prism, and this prism is having some angle which we otherwise call as the angle of prism, represented with capital A, right? And see చూడండి, ఇప్పుడు ఇది మన రెడ్ లైట్ రే కదా, రైట్? ఇప్పుడు ఈ రెడ్ లైట్ రే ప్రిజం లేకపోయి ఉంటే ఈ డైరెక్షన్లో వెళ్ళిపోయేది, రైట్? ప్రిజం ఉంది కాబట్టి ఈ డైరెక్షన్లో బెండ్ అయింది, బెండ్ అయిన తర్వాత మళ్ళీ బెండ్ అయింది, బెండ్ అయ్యి ఈ డైరెక్షన్లో వెళ్ళిపోయింది. ఇప్పుడు ఈ లాస్ట్లో ఎమర్జెంట్ లైట్ రే ఏ డైరెక్షన్లో వెళ్ళిందో ఆ లైట్ రేని మనం ఎక్స్టెండ్ చేస్తే అవర్ ఇనిషియల్ లైట్ రే మనం ట్రేస్ బ్యాక్ చేసాం కదా, మనం దాన్ని ముందుకి ట్రేస్ చేసాం కదా. సో ఆ లైట్ రే అండ్ దిస్ లైట్ రే, బోత్ ఆఫ్ దెమ్ విల్ మీట్, రైట్? అండ్ నౌ ది యాంగిల్ దట్ దే బోత్ విల్ మేక్, ఓకే, విల్ టాక్ అబౌట్ మన ఇన్సిడెంట్ లైట్ రే ఎంత బెండ్ అయింది, ఓకే, దాని గురించి మాట్లాడుతుంది అది, రైట్? మన ఇన్సిడెంట్ లైట్ రే ఎంత యాంగిల్ బెండ్ అయింది టు బికమ్ అన్ ఎమర్జెంట్ లైట్ రే. మన ఇన్సిడెంట్ లైట్ రే ఎమర్జెంట్ లైట్ రే అవ్వడానికి ఎంత యాంగిల్ బెండ్ అయింది, దట్ ఈస్ వాట్ వి కాల్ యాజ్ ది యాంగిల్ ఆఫ్ డీవియేషన్. ఇట్ ఈస్ రిప్రజెంటెడ్ విత్ స్మాల్ డెల్టా సింబల్. ఎస్ అన్నపర్తి, యూ కెన్ లిసన్. Okay, so now this angle of deviation ఉంది కదా, ఈ angle of deviation will depend on few parameters, like it depends on few other quantities as well, okay, such as it will depend on the refractive index of the prism. Over here we have a prism, right? We have a rectangular prism, right? And this prism will have a refractive index. Now what is the refractive index, students? Let us recall quickly. Refractive index is a factor by which the speed of light will get reduced, okay? ఒకవేళ మన గ్లాస్ రిఫ్రాక్టివ్ ఇండెక్స్ ఇస్ 1.5. వాట్ ఇట్ మీన్స్ ఇస్ మన లైట్ రే అనేది వాక్యూమ్ నుండి గ్లాస్కి వెళ్తున్నప్పుడు దాని స్పీడ్ అనేది 1.5 టైమ్స్ రెడ్యూస్ అయిపోతుంది, ఓకే? ఒక మీడియం రిఫ్రాక్టివ్ ఇండెక్స్ 2 ఉందనుకోండి, దాని అర్థం ఏంటి? ఒకవేళ వాక్యూమ్లో దాని స్పీడ్ 3 × 10⁸ మీటర్ పర్ సెకండ్ ఉంటే, రైట్? సో ఇప్పుడు లెట్ us say glass refractive index, it is not equal to 2, but I am telling you if it is equal to 2, the speed of light in glass will be equal to 1.5 × 10⁸ meter per second, which you see it is exactly half. Ante refractive index is a factor by which speed of light will get reduced. Ante when I say glass refractive index is 2, okay, what I really mean is when light is going from vacuum into glass, its speed is getting reduced by half. It is getting reduced by 2 times, right? So which will be 1.5 × 10⁸. Okay, that is a reduced speed with which light will go in prism. Okay, ఇంకొకటి మీరు అర్థం చేసుకోవాల్సింది ఏంటంటే, సో దిస్ నంబర్ ఉంది కదా 1.5 × 10⁸, రైట్? సో వీ జనరలీ కన్సిడర్ yellow light ray, it is normally a white light. Now that white light is having 7 different colors in it, right? Out of which out of which this particular number that I'm telling you, or the refractive index of this glass that I have taken as 2, okay, it is only with respect to the yellow light of that white light. Different colors of light వచ్చి మన prism పైన హిట్ అవుతాయి, right? With respect to those colors, మన refractive index of the prism will change. Okay, refractive index of glass necessarily all the time 1.5 undalani, it is not correct. Okay, similarly refractive index of water, if you know refractive index of water is some number, that is not all the time correct, because it is only correct with respect to one specific color, right? Because you will know that speed of speed of different colors of light is different in different medium. But if you talk about vacuum, ఒకవేళ vacuum లో కన్సిడర్ చేస్తే అన్ని light colors they will go at a same speed. But if they are going in some random medium like air lo velte or water lo velte, right? So you will notice that their speeds are different, and what speeds different ఉండడం వల్ల ఏమవుతుందంటే you will be noticing bending of light and dispersion of light, right? So we will just come to see what is dispersion of light in a quite a little while, right? So first let us quickly check this particular maybe I don't know if you can see me. Can you all see me, students? See students, if you will consider this triangle, let us say this is O, this is M, this is N, right? If you notice that triangle, so you could see that, see this is the triangle, this is the inside triangle, right? And then there is another triangle, this is the outside triangle, this is another triangle, right? So in triangle OMN, right, you can see that this particular angle, this is your incident light ray, right? And this was your normal, right? And this is the extension of that incident light ray, right? And you saw that this was the refracted light ray that was going like this, right? So this was the angle of incidence, right? And this was the angle of refraction. This is R1, this is I1, right? ఇక్కడ దాకా వచ్చిన తర్వాత మళ్ళీ the incident light ray will just go like this, right? And this is your normal again, this is your second incident light ray, right? So now you will notice that if you will extend this particular horizontal line, right? So you will notice that this angle and this angle are vertically opposite angles, right? So if this is R1, this will also be R1, right? Similarly over here, if this is R2, this will also be R2, right? So how do you find this angle, this inside angle of this triangle? This was triangle OMN, ఇక్కడ నేను చెప్పినట్టు this is OMN, right? So to find this angle will be equal to what? It will be nothing but this total I1, minus this small angle that is R1. ఈ పెద్ద యాంగిల్ లో నుండి చిన్న యాంగిల్ తీసేస్తే మనకు వచ్చేది ఈ యాంగిల్, రైట్? సో ఈ యాంగిల్ వచ్చింది కాబట్టి this angle and this angle will be equal, right? So I1 minus R1, that angle is I1 minus R1, right? Now this angle, we know one of the properties of a triangle, right? Sum of interior angles will be equal to the exterior angle that is outside this triangle. See over here, the exterior angle is this delta. ఈ triangle ki e angle plus e angle will give you the result of the exterior angle that is present over there, that is outside, that is your delta, right? So that is what we are doing, right? So one of the interior angle is I1 minus R1, right? So this plus here, now on the right side also you will have to find, see this angle is already found, now you will have to find this angle, right? Now this angle will be equal to what? That angle will be equal to nothing but I2 minus R2. You will be getting this angle, and if this angle is I2 minus R2, this angle will also be I2 minus R2, right? So this will be I2 minus R2, right? So now sum of these interior angles will be equal to the exterior angle, that is delta, right? So if you will do the math properly, so you can write it as I1 plus I2 minus of R1 plus R2. This is equal to delta, right? This is your first equation, let us consider, right? Now similarly, let us take one more triangle, that is this triangle, a feather triangle. Now we are talking about this feather triangle, right, which is triangle AMN. Okay, now in triangle AMN, so you know that sum of angles, sum of all the interior angles of a triangle is equal to 180 degrees, right? So this triangle like this, if you'll consider, you will notice that this side here is perpendicular and E angle అనేది R1, similarly this side is also perpendicular 90 degrees, right? దాంట్లో మళ్ళీ ఈ యాంగిల్ అనేది మన R2, sorry, this angle, right? So this angle is equal to R2, right? So this is 90 minus R2, so ఈ యాంగిల్ ఏమవుతుంది 90 minus R2, similarly ఈ యాంగిల్ కూడా ఏమవుతుంది 90 degrees minus this R1, 90 degrees minus R1. So angle A plus 90 minus R1 plus 90 minus R2 is equal to 180 degrees, right? So angle A plus 180 degrees minus R1 plus R2 is equal to 180 degrees. 180 will get cancelled, right? So now you are left with angle A is equal to R1 plus R2. Angle A is equal to R1 plus R2. Now this will be your second equation, right? So now if you will add both these equations, first equation and second equation, see you can see in the first equation you can replace R1 plus R2 with A because you already have A in the second equation, right? So you will be left with I1 plus I2 minus A is equal to delta, or otherwise A plus delta is equal to I1 plus I2. This is your third equation. What are we deriving here? We are deriving the refractive index of a prism formula, right? So angle of incidence plus angle of emergence, angle of incidence plus angle of emergence. This is a relationship. ఇక్కడ మనకు వచ్చిన relationship, it is a relationship between the angle of the prism, right, and the deviation, angle of deviation of a prism, right, and the incident angle and the emergent angle. చూడండి మనకు అన్ని పారామీటర్స్ ఇక్కడే ఉన్నాయి. This is the angle of prism, this is the angle of deviation, this is the incident angle, E incident light ray, and I2 is what? I2 is the emergent angle, this E, small e, right? So we have a relationship, we have a formula that relates all of these 4 different parameters, right? So we can use this particular equation 3, right? So to get the final derived formula, right? See students, we know Snell's law. According to the refraction concept, we know Snell's law. See, if light is incident from a medium whose refractive index is I1 or N1, okay, light అనేది ఈ particular refractive index నుండి వచ్చింది, it is entering into some other medium whose refractive index is N2, okay. If light is going from air, ఒకవేళ మన outside medium air అవుతే, if this is equal to air, we know the refractive index of air is nothing but equal to 1, right? And for the other medium, we can consider that to be like N, right? So for this first surface, we can write N1 into I is equal to N2 into R1. This is I1, okay. Now N1 is what? N1 is air. So for air, refractive index is 1, right? Or otherwise here this should be, if you are not approximating the angles, if you are not doing the small angle approximation, then you will directly get the sine rule as well directly. So N1 into sin I is equal to N2 into sin R1, okay. So this one you will only get once you do the small angle approximation, Okay, so for now just remember, just we will only consider this particular equation, right? So n1 value, because it is air, so it will be 1, this will be sin I1, this will be equal to n2 we replace it with n because that is the refractive index of that prism, this will be equal to sin R2, right? This same thing you can do it for the second surface. This is the first surface, right? So for the second surface, it will be n sin R2, that will be equal to sin I2, right? So this will be fourth and this will be fifth equation, right? So now students, what I want you to focus on here, see, we know that this is the angle of deviation of a prism. This angle is the angle of deviation of a prism. Now what is angle of minimum deviation? Angle of minimum deviation is denoted with capital D. Okay, so angle of minimum deviation is this particular same deviation of the prism in that case when your incident angle and the emergent angles are equal. Okay, so whenever you find the angle of minimum deviation, that is capital D, angle of minimum deviation, angle of minimum deviation అనేది ఇంకొక word అండి. Okay, so which is represented with capital D. Just like how we had angle of deviation అనేది in all those cases when angle of incidence and angle of emergent are not equal, in all those cases you will call that angle as angle of deviation. Okay, but in those cases when I1 is equal to I2, in those cases you will be calling that same angle as angle of minimum deviation. Okay, so now if you want to find the angle of minimum deviation, so we are like trying to find this case for that angle of minimum deviation, right? Why? To make our problem a little easier. Instead of having many unknowns, we are just like reducing the number of unknowns. Only for that reason we are considering the angle of minimum deviation in this case, right? So to convert this delta, small delta, into capital D, to convert it into an angle of minimum deviation, mana I1 inka I2 values will be equal. Okay, so now let us suppose I1 is equal to I2. Okay, if I1 is equal to I2, obviously R1 will also be equal to R2, right? So now let us substitute these parameters in equation 3, and 2, right? So in that case, now what do you get? You get from equation 3, you see A plus delta is equal to I1 plus I2, right? Now that you can replace that with, A plus D is equal to I1 plus I2, because we are replacing I2 with I1, or otherwise I1 with I2, so you can write I2 as I1 only, right? So this will be equal to A plus D is equal to 2I1. Yes students, and also from this equation, A is equal to R1 plus R2, you can write A is equal to 2R1. Right, so from here R1 can be written as A by 2, right? And from here I1 can be written as A plus D by 2, right? And now what are we left with? We are just left with substituting this value. Okay, so I1 వచ్చింది, R1 వచ్చింది, right? So if you will substitute these values of I1 and R1 in this equation 4, you will be getting the refractive index or the refraction formula, right, for a prism. Let us do that. You will be getting sine of A plus D by 2, that will be equal to sine of n sine of R2. Sorry, this is R1. Here we already have R1, right? Yeah, n sine of A by 2, right? So from here n will be equal to, that is refractive index of the prism will be equal to sine of angle of the prism plus angle of minimum deviation divided by 2, whole divided by 2, and whole divided by sine of E by 2. For Telangana board students, this derivation can be asked in your exam, right? So that is the reason why I have derived this particular formula, right? And for all the other boards, questions from this particular case will be very little asked, right? But if it is the most difficult question that is asked from human eye on the Colourful World, so it can be this. Specifically ఒకవేళ prism, angle of prism గురించి అడిగితే, right students? So for Telangana board, this is very important, right? So this is the only derivation that we'll be having throughout the session, and then after this everything will be all conceptual concepts that will be taught. Okay na? Okay. So ఈ డెరివేషన్ లో జస్ట్ ఇక్కడ మాత్రమే, సో వెన్ యూఆర్ కన్వర్టింగ్ ఇట్ ఫ్రమ్ ది యాంగిల్ ఆఫ్ డివియేషన్ టు యాంగిల్ ఆఫ్ మినిమం డివియేషన్, అక్కడ మాత్రం మనం ఈ పాయింట్ మెన్షన్ చేయాలి. ఓకే, సో లెట్ us కన్సిడర్ దట్ angle of deviation as angle of minimum deviation, and we know that whenever we have an angle of minimum deviation, I1 will be equal to I2. Just you have to mention this point. Okay. Okay. So over here now we start the concept of dispersion of light. Now what is dispersion of light, students? What is dispersion of light? Dispersion of light is nothing but splitting of white light into its constituent colors. And white light is having 7 different colors in it. ఆ 7 colors ని మనం కంబైన్ చేస్తే according to Newton's experiment you get a white light, right? But ఆ white light ని మనం స్ప్లిట్ కూడా చేయొచ్చు, దాన్ని సెపరేట్ కూడా చేయొచ్చు, 7 colors ని సెపరేట్ చేయొచ్చు, రైట్? ఈ సెపరేట్ అవుతున్న ఫినామినన్ ని డిస్పర్షన్ ఆఫ్ లైట్ అని అంటాము, రైట్? సో dispersion of light is a splitting of white light into its constituent colors, right? So why is that splitting happening? It is because of the refractive index. It is because of the change in refractive index of a particular object with respect to different colors of the light. నేను ఇందాక ప్రీవియస్లీ చెప్పాను కదా, రెడ్ లైట్ కి విత్ రెస్పెక్ట్ టు రెడ్ లైట్ ద రిఫ్రాక్టివ్ ఇండెక్స్ ఆఫ్ గ్లాస్ మే బి 1.2, with respect to yellow light the refractive index of glass may be 1.5, right? With respect to violet light the refractive index of glass may be 2.2, right? So for the same material glass, refractive index అనేది చేంజ్ అవుతుంది with respect to what color of light is coming and hitting it, right? So అలా refractive index with respect to different color of the same object glass చేంజ్ అవుతుంది కాబట్టి మన లైట్ రేస్ అనేవి డిఫరెంట్ డైరెక్షన్స్ లో బెండ్ అవుతాయి. ఎప్పుడు ఏ కేసులో అంటే when you are like incidenting a light onto a prism, you will notice that light rays are getting divided, right? You will notice that the light rays are getting divided, they are getting separated, right? This phenomenon of light rays getting separated is what we call as dispersion of light. Okay, we will check clearly ఏ లైట్ రే ఎక్కడికి వెళ్తుంది, ఎక్కడ సెపరేట్ అవుతుంది, we will see all of that. Okay, before that let us solve this question. So ఇక్కడ మనకి సురేష్ ఉన్నాడు. Yes students, so Suresh observes and records how white light is split into different colors when it passes through a prism. So ఇక్కడ ఒక ప్రిజం ఉంది, ఒక వైట్ లైట్ ఉంది. సో వైట్ లైట్ ని మనం ఇలా ఇన్సిడెంట్ చేసినప్పుడు this white light got split into 2 different lights, as you can see in this particular image, right? This white light got split into 2 different colors, right? Now this color is going a little up and this color is going a little up, little down, right? So you will have to identify x and y. X is which color and y is which color? Come on students. Yes, so x is which color and y is which color? Suresh observes and records how white light is split into different colors when it passes through a prism, right? So identify the colors x and y. So you will notice that with understanding this particular concept, okay, so you will notice that violet will bend to a greatest degree. Violet light అనేది చాలా ఎక్కువగా bend అవుతుంది and it will settle at the bottom, right? And red light will stay at the top. Okay, so you should know that violet light is having the shortest speed when compared to all these colors speed. Okay, red light ki speed అనేది ఎక్కువ ఉంటుంది. Okay, red light ki speed అనేది ఎక్కువ ఉంటుంది, it is having a longer wavelength, right? So violet light is having a shorter wavelength. So shorter wavelength light ray, violet, right? So violet light, its speed will get reduced by a greater degree when it is coming from vacuum into glass. Okay, vacuum into glass కి వెళ్ళినప్పుడు దాని స్పీడ్ అనేది it will get reduced by a greater degree. When it is getting reduced by a greater degree, so what does that mean? Speed అనేది ఇంత ముందు 3 ఉండే, ఇప్పుడు 1.5కి వెళ్ళిపోయింది. మన రెడ్ లైట్ దేమో ఇంత ముందు 3 ఉంటే 2కి వెళ్ళిపోయింది స్పీడ్, అంతే కదా. మన వైలెట్కి ఏమో 1.5 ఇంకా కిందికి వెళ్ళిపోయింది, చాలా తక్కువ స్పీడ్ అయిపోయింది. కాబట్టి బెండింగ్ అనేది ఎక్కువ ఉంటుంది. ఎందుకు? తొందరగా ఇట్ వాంట్స్ టు గో త్రూ దట్ మీడియం అండ్ కమ్ బ్యాక్ ఫ్రమ్ ఇట్. ఓకే, తొందరగా ఆ మీడియం నుండి వెళ్ళిపోయి దాంట్లో నుండి బయటకు వచ్చేయాలని. రైట్, నౌ డు నాట్ గెట్ కన్ఫ్యూజ్డ్ విత్ దిస్. ఇక్కడ మనకి డిస్టెన్స్ తక్కువ ఉంది కదా, ఇక్కడ వైలెట్ ఇంకా ఎక్కువ డిస్టెన్స్ ఎందుకు ట్రావెల్ చేస్తుంది? సి, ఇట్స్ నాట్ ఆల్ ద టైమ్ విత్ ద లెంత్ ఆఫ్ డిస్టెన్స్ ఇట్ విల్ ట్రావెల్. ఇట్ విల్ ఆల్సో డిపెండ్ ఆన్ ది ఆప్టికల్ డెన్సిటీ ఇన్సైడ్ ఇట్. ఓకే, మనకి ఎక్కడైతే షార్టెస్ట్ డిస్టెన్స్ ఉందో అక్కడ ఆప్టికల్ డెన్సిటీ విల్ బి లెస్, రైట్. సో wherever you have will be less or will be more. Okay, wherever you have a lengthier distance అక్కడ మనకి ఆప్టికల్ డెన్సిటీ తక్కువ ఉండొచ్చు, రైట్. సో ఆప్టికల్ డెన్సిటీ ఈస్ డిఫరెంట్ ఫ్రమ్ మాస్ డెన్సిటీ స్టూడెంట్స్. మనకి మాస్ డెన్సిటీ తెలుసు, రైట్, డెన్సిటీ ఈజ్ ఈక్వల్ టు మాస్ అపాన్ వాల్యూమ్, right. So that mass density is completely different from optical density. Optical density, when I say, it is how restricted are the light rays facing when it is going through that particular object. Okay, it deals with optics. Optics is a word that is used for light. Okay, so for light, how much is that restriction? That is what your optical density is about, right. So you will have to name these colors. So let us first name these colors here and then we'll get back there. Okay, or otherwise you can directly solve this question. So here we have a prism and this light rays got split like this, right. Now what is this lower light end? Lower light end, so I'll tell you that the lower light end over here is violet. This Y is violet, and this X will be red. Okay, and all the other colors will lie in between these two light rays. All the other colors will lie in between these two light rays, right. So name the different colors that come out of the prism, students. So first from the bottom you will have to write VIBGYOR: violet, indigo, blue, green, yellow, orange, red. These are the 7 different colors. Okay, VIBGYOR starting from bottom. When you are having a white light like this, మన వైట్ లైట్ ఇలా ఈ డైరెక్షన్ లో మనం ఇన్సిడెంట్ చేసినప్పుడు, right, so light rays will bend, right, and they will split, and this is how the light rays are spread. Okay, so violet, indigo, blue, green, yellow, orange and red. This is how the white lights are split. Great, Amulya. Okay, so how do you find experimentally the refractive index of material of a prism? So we have seen already in the previous case, right. So over here this was the experimental proof, okay, of finding the refractive index of a prism. Okay, first you will be getting I1 plus I2 is minus R1 plus R2. I1 plus I2 minus R1 plus R2 is equal to delta, right. And then later on we got A equal to R1 plus R2. A is equal to R1 plus R2. These are the important equations, right. So from what all we got, right, and the other one will be A plus D. A plus delta will be equal to I1 plus I2. Right, and the other one will come out from this Snell's law, sin I1 equal to n sin R1. Right, now chromatic aberration. Now what is chromatic aberration, students? See students, manam normal ga like in this concept also, that is human eye and the colorful world, manam last class lo we talked about myopia, we talked about hypermetropia, we talked about presbyopia. We've also solved many problems related to those defects of eye, right. So manam spectacles ni design chesamu, right. So we have designed spectacles, right. So from lens maker's formula, right, from your refraction of light at curved surfaces, mana previous chapter lo we have derived a lens maker's formula as well, right. So lens maker's formula is very important, especially to the lens makers, okay, the people who make the lens, okay, వాళ్ళకి ఆ formula is very important, right. So with the help of the refractive index, with the help of the angle of incidence, angle of refraction, so వాటిని అన్ని concepts ని involve చేసి they will prepare the lens in such a way that that lens is having a proper exact focal length that is completely associated with your human eye, okay, or whatever the human eye is, right? So with respect to different defect of a human eye, exactly to that particular human eye ఏదైతే లెన్స్ ఫిట్ అవుతుందో, ఏ ఫోకల్ లెంత్ అయితే ఎగ్జాక్ట్గా ఫిట్ అవ్వాలో, సో ఆ లెన్స్ని మనం డిజైన్ చేసి మనం ఇచ్చేస్తాం, రైట్? సో మనకి ఒక విషయం తెలుసు ఏంటి అంటే, ఒకవేళ ఫోకల్ లెంత్ ఆఫ్ ద లెన్స్ ఇస్ రెడ్యూసింగ్, focal length of a convex lens, if it is getting reduced, you know that the lens will become thick like this, right? ఒకవేళ lens thick అవుతే focal length reduce అవుతే, we know that power is inversely proportional to focal length. We know power is inversely proportional to focal length. This focal length should be in meters, then you will be getting power in diopters, right? So you see, power is inversely proportional to focal length. If focal length is small, power will be more, right? So ఒకవేళ focal length మనం ఎంత తక్కువ చేస్తే అంత పవర్ఫుల్ మన లెన్స్ విల్ బికమ్, రైట్? బట్ ఈ పవర్ ఆఫ్ ద లెన్స్ అనేది మనం ఎంత పవర్ చేయొచ్చు, ఎంత హై చేయొచ్చు, ఓకే? మనకు అనిపిస్తుంది ఓకే అలా అయితే వాట్ వీ షుడ్ జస్ట్ డూ ఇస్, మనం we will keep on reducing the focal length of the lens. When we will keep on reducing the focal length of the lens, you will notice that the power of the lens will keep on increasing, రైట్? అలా అయితే మనకి ఇన్ఫైనైట్ పవర్ దాకా కూడా మనం వెళ్ళిపోవచ్చు, రైట్? సో దిస్ ఇస్ సంథింగ్ దట్ వీ విల్ నార్మలీ థింక్, రైట్? ఇన్ఫైనైట్ పవర్ ఆర్ ఎంత పెద్ద పవర్ కావాలంటే అంత పెద్ద పవర్ వరకు వెళ్ళిపోవచ్చు, రైట్? బట్ స్టూడెంట్స్, టు ఇంక్రీజ్ దట్ పవర్ వాట్ ఆర్ యూ డూయింగ్? టు ఇంక్రీజ్ దట్ పవర్ మనం మన లెన్స్ని కూడా థిక్గా చేస్తున్నాం, ఇలా లెన్స్ని కూడా ఇలా థిక్గా చేస్తున్నాం. మనం మిర్రర్ కాన్సెప్ట్లో చూసాము దట్ యువర్ అపర్చర్ ఆఫ్ ద మిర్రర్ షుడ్ నాట్ బి సో బిగ్ ఆర్ సో స్మాల్, రైట్? యువర్ మిర్రర్ షుడ్ లుక్ యాజ్ ఇఫ్ ఇట్ ఈస్ లైక్ ఎ స్ట్రైట్ లైన్, రైట్? మిర్రర్ కర్వేచర్, కాన్వెక్స్ సర్ఫేస్ అన్న కాన్వెకేవ్ సర్ఫేస్ అన్న ఇలా అది కర్వ్డ్గా ఉండకూడదు. ఉంటే వీ విల్ బి గెటింగ్ ఇమేజెస్, more than one images very close to one another, and you will be getting blurred images, right? In the similar way, even in a convex lens or a concave lens, right? When you have a lens very thick or very thin, right? When you have the lens which is like very thick like this, right? For a concave lens, if it is like so thin like this at the center and edges are like this, right? In those cases, you will be encountering with an error called chromatic aberration. What is this chromatic aberration? Chromatic aberration is nothing but splitting of these white light into its constituent colors, and these white lights, they are not recombining again. ఈ వైట్ లైట్స్ ఎక్కడ ఎలా అయితే స్ప్లిట్ అయిపోయాయో అలా స్ప్లిట్ అయిపోయి రెడ్ వెళ్ళి రెడ్ దగ్గర ఇంటర్సెక్ట్ అవుతుంది, గ్రీన్ వెళ్ళి గ్రీన్ దగ్గర ఇంటర్సెక్ట్ అవుతుంది, బ్లూ అనేది బ్లూ దగ్గర ఇంటర్సెక్ట్ అవుతుంది. సో యూ ఆర్ గెటింగ్ డిఫరెంట్ కలర్స్ దట్ ఆర్ కమింగ్ అవుట్ లైక్ దిస్. సో చూడండి, ఈ పిక్చర్ని మనం చూస్తే మనకు అర్థమైపోతుంది. సో a picture like this in video games, right? So you must have seen that if your racing car is like that, there are some colors, okay, that are closely at the borders of that particular racing car, okay? ఈ కలర్స్ అనేవి మనకి ఎందుకు వచ్చాయి? మనం ఏదైతే లెన్స్ తోటి మనం ఈ కెమెరా షాట్ చేస్తున్నామో, రైట్? ఫ్రమ్ విచ్ ఎవర్ కెమెరా యు ఆర్ రికార్డింగ్ దిస్ రేసింగ్ వీడియో, రైట్? సో that camera's lens పవర్ అనేది చాలా ఎక్కువ ఉన్నట్టుంది. ఎక్కువ ఎందుకుంది? దిస్ పర్సన్ ఇస్ ట్రైంగ్ టు జూమ్ ద రేసింగ్ కార్ కదా. రేసింగ్ కార్లో కెమెరామ్యాన్ ఇస్ నాట్ అలౌడ్ టు గో ఆన్ టు ద ట్రాక్, right? He will stay somewhere else, right? He will zoom the images, right? So what do they do is they will try to increase the power of the lens so that they can capture very much zoomed in, much good quality images, right? But there are still problems with that. The problem is chromatic aberration, right? So you will notice that the colors are like split like this, right? So this particular phenomenon is called chromatic aberration, and this is mostly phenomenon in thick lens, right? So failure of the lens to focus all the colors at the same point because of increasing the power, right? So split అయిన disperse అయిన light rays ని మళ్ళీ ఒక్క పాయింట్ దగ్గర ఫోకస్ చేయడానికి ఇబ్బందికరంగా అయిపోతుంది. It's all because you increase the thickness of the convex lens. Okay, so dispersion of light అనేది అయింది. ఓకే, ఇక్కడ కూడా మనం ప్రిజం దగ్గర చూసాము. సో we got some dispersion of light, right? So ఇప్పుడు see, it was Newton was a scientist. So he was the first person to discover this phenomenon of dispersion of light. He was doing experiments and he came out to be seeing that white light అనేది 7 different colors కి split అయిపోయింది, right? And Newton was the same person to recombine these light rays and get a white light again. He was the same person. He again performed an experiment. He put then our first prism పక్కనే ఇంకొక prism పెట్టాడు. This is an inverted prism, right? Now when you keep an inverted prism one after the other, right? So splitting of white light phenomenon and dispersion of light అని అన్నాము, right? So this recombining, ఈ వైట్ లైట్స్ ని మళ్ళీ కంబైన్ చేసేసి ఈ 7 different కలర్స్ ని మళ్ళీ కంబైన్ చేసేసి అగైన్ మనకి మళ్ళీ వైట్ లైట్ వస్తుంది కదా. సో ఈ పర్టికులర్ ఫినామినన్ ని వి కాల్ ఇట్ as recombination of light, right? So what if మనకు క్వశ్చన్ రావచ్చు ఎగ్జామ్ లో, like what if we use a set of two prisms, right? One is erect prism ante ninchoni unna prism, and the other one is inverted. Okay, straight prism, one more is inverted prism. So what happens in that case, right? So you will notice that recombination effect will happen, dispersion and recombination effect will happen, right? And finally you will be getting your white light back again. Now students, look at this. See, we know about light ray in rectangular prism. Normal ga, like, not if it is not a prism, like rectangular glass slab especially. Okay, మనం ఒక గ్లాస్ స్లాబ్ నుండి లైట్ రేస్ అనేది ఇలా పాస్ చేస్తే, వైట్ లైట్ మనం ఇలా పాస్ చేస్తే, ఈ వైట్ లైట్ అనేది ఇలా రిఫ్రాక్ట్ అయ్యి మళ్ళీ ఇక్కడ నుండి ఇలా ఇలా స్ట్రైట్గా వచ్చేసింది, రైట్? అక్కడ మనము ఈ డిస్పర్షన్, స్ప్లిట్టింగ్ ఆఫ్ వైట్ లైట్ ఇంటూ డిఫరెంట్ కలర్స్ మనం ఆ ఫినామినన్ చూడలేదు. ఎందుకు చూడలేదంటే అక్కడ మనకి ఈ ఇన్సిడెంట్ సర్ఫేస్ ఏదైతే ఉందో, ఇన్సిడెంట్ సర్ఫేస్ ఇంకా ఈ రిఫ్రాక్టెడ్ సర్ఫేస్, ఇక్కడ ఎమర్జెంట్ సర్ఫేస్ ఉంది కదా, ఇవి రెండు ప్యారలల్ ఉన్నాయి, రైట్? సో వెన్ యూ హ్యావ్ ప్యారలల్ సర్ఫేసెస్, both incident surface and the emergent surface, right? In that case you will only notice that white light is coming in and white light is coming out, right? And now that same thing you can also see here. This is the first surface, incident surface of this prism, and this is the emergent surface. You see these two are parallel, and you get white light out and you send white light in, right? ఆ కలర్స్ ని మనం చూడాలంటే దీన్ని కూడా మనం ఇలా బ్రేక్ చేస్తే, ఈ రెక్టాంగులర్ ప్రిజమ్ ని ఇలా మధ్యలోకి ఇలా బ్రేక్ చేస్తే, then you will be noticing బ్రేక్ చేసి కొంచెం డిస్టెన్స్ మెయింటైన్ చేస్తే, in that gap you will be noticing those other 7 different colors. Yes students, so this splitting of white light will only happen when the incident surface and the emergent surface are making some other angle other than 0 degrees. See, parallel lines, what angles do parallel lines make? They make 0 degrees between them, right? If you are having an angle which is other than 0 degrees, some other angle, random angle, in that case with some angle of prism, okay, angle of prism icham ankondi other than 0 degrees, then you will be getting dispersion of light happen, right? And if you want to cover up that reduced angle with another inverted prism, then you will be getting the recombination effect. Right students, so speed of different wavelengths in different media, right? So speed of different wavelengths, see, white light is having 7 different colors, right? So red light is having the highest wavelength, red is having highest wavelength, right? And violet is having the shortest wavelength, right? And all the other colors, their wavelengths will be in those ranges. Over here we have a question students. Two scientists are trying to obtain the refractive index of a glass slab. Left side ఒక scientist కూర్చున్నాడు, right side ఒక scientist కూర్చున్నాడు. Left side అతని person is using a red laser light, right side person is using a violet laser light. One of them uses a red light and the other one uses a blue light, okay, blue or violet, whatever it is, okay, which is towards the shortest wavelength. Will they obtain the same value of refractive index of the glass slab? ఇప్పుడు ఇక్కడ ఈ scientist he is using a glass slab, he is also using the same glass slab, right? కానీ ఇప్పుడు మనం refractive index of that glass slab find out చేస్తున్నాం. ఆ refractive index of glass slab same ఉంటుందా students? Will it be same? In your textbooks you will be noticing refractive index of glass slab is 1.5 or whatever value, but is that value constant? No, that value is with respect to yellow color light, right? Now with respect to different colors you will notice the refractive index will be different. Okay, we know that red light will bend the least, right? And violet light will bend the most, or blue light will bend the most, right? అంటే మన బ్లూ లైట్ కి రిఫ్రాక్టివ్ ఇండెక్స్ ఎక్కువ వస్తుంది అండ్ రెడ్ లైట్ కి రిఫ్రాక్టివ్ ఇండెక్స్ తక్కువ వస్తుంది. తక్కువ రిఫ్రాక్టివ్ ఇండెక్స్ వచ్చిందంటే ఏంటి? మన లైట్ రే విల్ గెట్ రెడ్యూస్డ్, ద స్పీడ్ ఆఫ్ ద రెడ్ లైట్ రే వెన్ ఇట్ ఈస్ గోయింగ్ ఫ్రమ్ వాక్యూమ్ ఇన్ టు దిస్ గ్లాస్ ఇట్ విల్ గెట్ రెడ్యూస్డ్ బై అ షార్టర్ వాల్యూ. స్పీడ్ ఆఫ్ ద లైట్ షార్టర్ వాల్యూ రెడ్యూస్ అయింది కాబట్టి మన బెండింగ్ కూడా షార్ట్ బెండింగ్ ఉంటుంది. దట్ ఈస్ వాట్ యూ షుడ్ నో, రైట్? సో హియర్ యూ సీ స్టూడెంట్స్, this is your red light, it is coming from vacuum. See, vacuum and air, the refractive index, the speed of light in both vacuum and air, it will be almost close, though there will be a difference. Nothing is faster than speed of light in vacuum, right? But still the change in the difference is very negligible. అందుకే మనం రెండింటిని సేమ్ అనుకుంటాం. The refractive index of vacuum and air is equal to 1. Okay, so if you pass a red light, right, red light will quickly pass through it, it will go fastest when compared to the violet light. Violet light is the slowest light, okay, in this particular glass, right? So you see speed of light is 1.99 into 10 to the power 8 meters per second. Okay, you can also see the refractive index. Refractive index of this glass with respect to red light is 1.51, a value which is smaller than the refractive index of glass with respect to violet light. వైలెట్ లైట్కి రిఫ్రాక్టివ్నెస్ ఎక్కువ ఉంది. రిఫ్రాక్టివ్నెస్ ఎక్కువ ఉందంటే ఏంటి? స్పీడ్ ఆఫ్ లైట్ విల్ గెట్ రెడ్యూస్డ్ బై అ గ్రేటర్ అమౌంట్, బై దిస్ మచ్ అమౌంట్. ఓకే రైట్. అంటే ఇప్పుడు దాని అర్థం ఏంటి అంటే మనకి స్పీడ్ ఆఫ్ లైట్ ఇన్ ఎయిర్లో ఏముంటుంది వాల్యూ? ఇట్ విల్ బి 3 × 10⁸ మీటర్ పర్ సెకండ్. ఓకే, సో ఇప్పుడు గ్లాస్లో రెడ్ లైట్ని పాస్ చేస్తే ఎంత అయింది? 1.99 అయింది. 1.99 ఎలా అయింది? వెన్ వీ డూ 3 × 10⁸ divided by 1.51. ఎందుకంటే స్పీడ్ ఆఫ్ లైట్ is getting reduced by 1.51 times, right? So if you'll do this math, you will get the answer 1.99. Similarly, for this case, 3 × 10⁸ refractive index, it is a factor by which the speed of light will get reduced. Now the violet light speed will get reduced by 1.53 times, and finally the reduced speed will be 1.96 into 10⁸ meters per second. Now cause of dispersion. The cause of dispersion is మన లైట్ రేస్ బెండ్ అయ్యాయి కదా, right? It's all because of the different wavelengths that they are having, right? And it is all because of the different wavelengths they are having. See over here, red light, it is having a less refractive index, that is 1.51, right? And violet light is having a more refractive index, 1.53, right? So red light will bend the least, less bending will happen, and your violet light will be having a more bending, right? So because not all the colors of the light are having the same refractive index, or they are not having the same wavelengths, right? So dispersion of light will happen. Dispersion of light will necessarily happen, right? But if you talk about the same in vacuum, you will notice that for all colors of light, the speed of light in vacuum is same, that is 3 × 10⁸ meter per second. All colors of light, violet, indigo, blue, green. Okay, so an astronaut is stranded on the moon. He observes moon pine nunchoni, he is observing a spaceship far away. Identify the color of the light that the astronaut should use to get help quickest. Moon paina tappipoyadu, right? Now he wants to go home. There is nobody near him. Can he keep shouting spaceship వెళ్తుంది, spaceship వెళ్తున్నాడు అతను, ఏ spaceship wait. So if he'll keep on shouting, will the spaceship wait? Will the spaceship wait for him? Spaceship cannot wait, because you know that sound cannot travel in vacuum, right? So the only thing that you can do is turn on light, right? ఇప్పుడు ఆ లైట్స్లో ఏ కలర్ లైట్ యూస్ చేయాలి? ఎందుకంటే మనం చూసాం కదా, ఇక్కడ రెడ్ లైట్ అనేది ఫాస్ట్గా వెళ్తుంది, వైలెట్ లైట్ అనేది స్లో అయిపోయింది స్పీడ్, రైట్? డిఫరెంట్ మీడియంస్లలో. బట్ we still saw that speed of light in all in vacuum is సేమ్ ఫర్ ఆల్ ద కలర్స్, రైట్? సో నువ్వు రెడ్ లైట్ యూస్ చేసినా, వైలెట్ లైట్ యూస్ చేసినా, బ్లూ లైట్ యూస్ చేసినా, ఏది యూస్ చేసినా ఇట్ డజంట్ మేక్ అ డిఫరెన్స్, రైట్? బికాస్ స్పీడ్ విల్ బీ ద సేమ్, right? So identify the color that the astronaut should use to get the help quick. So the color will be all the colors, irrespective of what color you use. You can use red, you can use blue, you can use yellow, you can use any color. Because this point is very important, for all colors, speed of light in vacuum is 3 × 10⁸ meter per second. Write down this statement in your notebook, students. మీ నోట్బుక్లో ఈ స్టేట్మెంట్ రాసుకోండి. Now what will happen if the prism is replaced by a sphere? Hello Anupati, welcome to the session. Hello Jilla. What will happen if the prism is replaced by a sphere? ఏది ఎక్స్ప్లెయిన్ చేయాలి అమూల్య? So over here we have a sphere, students, right? And then there is a light ray, right? This light ray, because of dispersion concept, light rays will split into its 7 different colors constituents, right? ఈ split light ray అనేది ఇలాగే continuous గా వెళ్తూ ఉంటుంది, and again the light rays will again bend, right? And then you will be getting all these colors like this, right? And now if you will put a screen like this over here, right? So you will notice all those colors V, I, B, G, Y, O, R. Why this is behaving the same way as that of the prism, or as that of the prism? See, you can see there is also one more curvature at the top. From top to bottom ఇంకొక curvature ఉంది. ఇక్కడ నుండి కూడా మళ్ళీ again there will be other light rays, right? They will also come and they will also keep splitting like this. అందుకే మనకి ఒకవేళ మనం ఒక సోప్ బబుల్ లో నుండి మనం లైట్ ని చూస్తే మనకి సోప్ బబుల్ లైక్ సర్కంఫరెన్స్ లో మొత్తం అన్ని డైరెక్షన్స్ లో we will be feeling all the colors. See, our soap bubble, whenever we will see, we will look at the soap bubble like this. So will colors ఇలా అవుతాయి borders లలో, right? Borders లలోనే అన్ని colors వచ్చేసి they will all sit here. Its curvature is designed in such a way that the reason is its curvature is designed in such a way that it has all the colors in it, right? But if you talk about a prism, that is not the case. If you talk about a prism, that is not the case, right? In prism you will notice that here there is light ray that is coming and this light ray will split in different directions like this, right? And then there is another bending and the light rays will go like this, right? And this is how the VIBGYOR will come here. Right. So what will happen if the prism is replaced by a sphere? So splitting of white light, that is dispersion of light rays will happen. And this will happen from both the surfaces, one side surfaces and from the top surfaces, right? And all in all, you will notice that the circumference of the whole sphere, or the perimeter in 3-dimensional, right? So will all be having these 7 different colors in it. Okay students, so water drop dispersion. So the same principle. So that sphere ni manam, if you convert into a droplet, a water droplet. So you know a water droplet will look exactly close to like a sphere, like a prism only. See, prism is like this, right? So here dispersion will happen, here dispersion will happen, here also dispersion will happen. The light rays will split, right? Light ray that is coming here, it will split, right? And now apart from dispersion, here also there is dispersion, light rays will split, right? And this light rays will keep coming out. Total light ray is assumed to be coming out, but here also there will be some light rays that will come out, right? And there will be some light rays that will get internally reflected, okay, like this. They'll go and they'll internally reflect, and again from here they will again get reflected back, right? And here they will get refracted back, and finally these light rays will come out, right? And this is the reason why you get rainbow formation, right? So over here you see here students, so we have a good picture, right? So this explains about this particular rainbow formation in a proper detail. Okay, so during the dispersion of white light through a drop of water, which of the following processes is not involved? Which of the following processes is not involved? So which processes? See over here, dispersion of light dispersion of light is happening. So tell me which is not involved here? Reflection, refraction, dispersion, recombination, TIR, PIR. Yes students, ఈ 6 ఆప్షన్స్లలో ఏ ప్రాసెస్ అనేవి ఇక్కడ ఇన్వాల్వ్ అవ్వవు. ఇక్కడ మనకు ఒక వాటర్ డ్రాప్లెట్ ఉంది, రైట్? ఇట్స్ లైక్ అ ప్రిజమ్, రైట్? సో వైట్ లైట్ ఈస్ కమింగ్, right? And this white light వచ్చి it is dividing into 7 different colors, and these 7 different colors here again after they go, they will hit this other surface of the prism, right? Then there is some other sort of phenomenon happening, right? మళ్ళీ అక్కడ నుండి మళ్ళీ ఇక్కడ వచ్చి ఇక్కడ మళ్ళీ ఇంకోటి ఏదో అవుతుంది, రైట్? అది ఏమవుతుంది? ఏమీ అవ్వట్లేదు. ఈ 6 ఆప్షన్స్ నుండి ఏమేమి అవుతున్నాయి, ఏమేమి అవ్వట్లేదు? చెప్పండి స్టూడెంట్స్, what all is happening from these colors and what all are not happening from those colors? Can somebody tell me? See over here, this white light is coming, right? And wherever there is a change in medium, మనకి మీడియం ఇక్కడ ఎయిర్ నుండి వాటర్ కి వెళ్తుంది, right? So air refractive index is 1, water refractive index is some number, right? So when there is a change in refractive index, by whatever the number of refractive index is, the factor by which the speed of light will get reduced is called the refractive index, right? మన వాటర్ రిఫ్రాక్టివ్ ఇండెక్స్ ఎంత ఉంటుందో, ఏదైతే నెంబర్ ఉంటుందో ఆ నెంబర్, బై దాట్ అమౌంట్ the speed will get reduced, and because speed got reduced, the light rays will bend, because the white light is having different wavelengths will bend at different degrees, right? Wavelengths అనేది bend అయ్యాయి, right? This bending and this splitting into constituent colors is what we call as dispersion, right? So dispersion అనేది అయింది, ఇక్కడికి dispersion అనేది అయింది, plus refraction కూడా అయింది. Along with dispersion, even refraction happened. Dispersion happened and refraction also happened, because light ray ila వెళ్ళేది, light ray ila bend అయింది కదా, so refraction is also there, right? Now what else is there? What is happening over here? Students, ikkada it is appearing as if all the light rays are getting reflected back. Okay, TIR is total internal reflection. PIR is partial internal reflection. This is total internal reflection అంటే ఒక సర్ఫేస్ ఉంటే ఒక లైట్ రే ఈ డైరెక్షన్ లో వచ్చిందంటే ఈ లైట్ రే టోటల్ గా ఆ లైట్ రే లో ఏమేం క్వాంటిటీస్ ఉన్నాయో అవన్నీ, all the colors are getting reflected back totally, 100% is getting reflected back. That is called total internal reflection. Partial internal reflection అంటే ఇలా లైట్ రే వచ్చింది అనుకో, రైట్? So you will notice that some quantity 100% light ray వచ్చింది అనుకోండి, right? So out of that 100%, maybe some 20% got refracted and it went like this, right? Only 80% got reflected back. This is called partial internal అంటే లోపల నుండి లోపలికి got reflected back, right? So you will not notice that total internal reflection will happen here. When a light ray is coming, you will still see that some of the light rays, because it is water droplet నుండి మనం లైట్ ని బయటికి పాస్ చేస్తున్నాం కదా, so water is not a opaque object, right? It is neither a 100% transparent object, right? So it's like translucent, right? So you can consider it like that, because there is no object on this earth, right, which is actually 100% transparent or 100% opaque, right? Some of the light rays will pass through them and some of the light rays will get reflected back, right? So partial internal reflection is happening here, right? So total internal reflection will not happen in this case. Question exam lo this will be a direct question, right? And reflection concept, is reflection happening? Yes. Partial internal reflection anta it is still reflection, right? And recombination అవుతుందా ఇక్కడ? No. ఇక్కడ ఈ కేసులో ఏమవుతుంది, ఇక్కడ ఏమేమి అవుతున్నాయి, ఇక్కడ రిఫ్రాక్షన్ అవుతుంది, because bending is there. Whenever there is bending, there is refraction, right? And dispersion is already there. డిస్పర్షన్ ఇక్కడ ఆల్రెడీ ఉంది. సో యూ నీడ్ నాట్ మెన్షన్ డిస్పర్షన్ అగైన్. ఆ డిస్పర్షన్ అనేది ఇక్కడ మెన్షన్ చేస్తే చాలు. హియర్ యూ కెన్ సే రిఫ్రాక్షన్ ప్లస్ డిస్పర్షన్. ఎస్, రీకాంబినేషన్ పిఐఆర్ అవుతుంది. ఎస్, పార్షియల్ ఇంటర్నల్ రిఫ్లెక్షన్ ఇస్ అవుతుంది. TIR is not happening. Yes, in exams. Good. So rainbow formation is all because of these colors. ఇప్పుడు ఈ కలర్స్ బయటకు వస్తున్నాయి కదా, రైట్? మనం ఇప్పుడు హ్యూమన్ ఐ ఏం చేస్తారంటే వీ విల్ స్టాండ్ ఫ్రమ్ హియర్ అండ్ వీ విల్ లుక్ ఎట్ దట్ వాటర్ డ్రాప్లెట్. ఈ వాటర్ డ్రాప్లెట్ నుండి ఒక లైట్ రే వచ్చి మనకి ఇక్కడ మన ఐలోకి వెళ్తుంది, రైట్? సో ఈ వాటర్ డ్రాప్లెట్ కిందే ఇంకో వాటర్ డ్రాప్లెట్ కూడా ఉంటుంది కదా, రైట్? సో దాంట్లో నుండి వచ్చిన కలర్ దాని కిందకి వెళ్ళి వచ్చి మన ఐలోకి వెళ్తుంది, రైట్? మళ్ళీ దాని కింద ఇంకొక వాటర్ డ్రాప్లెట్ ఉంటుంది. సో అలా ఫ్రమ్ ఎవ్రీ ఇండివిజువల్ డ్రాప్లెట్, సో డిఫరెంట్ కలర్స్, ఆల్ దోస్ కలర్స్ విల్ కమ్ అండ్ హిట్ యువర్ ఐ. మనం ఇలా కింద కూర్చున్నప్పుడు దాని కింద ఉన్న లైట్, కింద ఉన్న వాటర్ డ్రాప్లెట్స్ ఉంటాయి కదా, దాంట్లో నుండి వచ్చిన కలర్స్ మనకు తగులుతాయి, రైట్? బికాస్ ఆ కలర్స్ అనేది ఒక డైరెక్షన్లో వెళ్తున్నాయి, రైట్? ఇఫ్ యూ వాంట్ టు సీ దోస్ కలర్స్ యూ హ్యావ్ టు జంప్ అండ్ లెట్ దట్ లైట్ టు గెట్ ఇన్ టు యువర్ ఐ. అప్పుడే ఆ కలర్ మన లోపలికి వెళ్తుంది, రైట్? కాబట్టి మనం కింద కూర్చున్నా, పైన లేసినా, లేకపోతే జంప్ చేసినా కూడా మనకు రెయిన్బో కనిపిస్తుంది. కలర్స్ ఎలా ఉన్నాయో అలా కనిపిస్తాయి. అది ఎందుకంటే దేర్ ఇస్ నాట్ వన్ డ్రాప్ ఇన్ ద స్కై, దేర్ ఆర్ మెనీ డ్రాప్స్ ఇన్ దట్ హోల్ లైన్, రైట్? ఒక డ్రాప్ మిస్ అయితే ఇంకొక డ్రాప్ నుండి ఆ మిస్ అయిన కలర్ మనకు లోపలికి వెళ్ళిపోతుంది. దట్ ఈస్ హౌ యూ విల్ బి నోటీసింగ్ దట్ రెయిన్బో, రైట్? సో ఓవర్ హియర్ we have a question, students. Two persons are reporting a robbery that occurred when a rainbow was seen in the sky. ఇక్కడ మనకి రెయిన్బో ఫార్మ్ అయింది, రైట్? సో ఐడెంటిఫై ద లయర్. ఎవరు లయర్ ఇక్కడ? పర్సన్ 1 ఏమంటున్నాడంటే ద రాబరీ హ్యాపెండ్ at 5 PM. పర్సన్ 2 ఏమంటున్నాడంటే ద రాబరీ హ్యాపెండ్ at 12:30 PM. హూ ఇస్ ద లయర్, స్టూడెంట్స్? Two persons are reporting a robbery that occurred when a rainbow was seen in the sky. ఆ రెయిన్బో ఎప్పుడైతే స్కైలో కనిపించిందో ఆ టైంలో ఈ సూపర్ మార్కెట్లో దొంగతనం జరిగింది, రైట్? సో ఇద్దరు విక్టిమ్స్ ఉండే, రైట్? సో వీ డోంట్ నో ఇఫ్ దే ఆర్ విక్టిమ్స్ ఆర్ వన్ ఆఫ్ దెమ్ ఇస్ కల్ప్రిట్, రైట్? Police officer, when he was asking the question, when did the robbery happen, right? So one of the persons told that the robbery happened at 5 PM, right? ఇతను అనుకుంటా అని చెప్పట్లేదు, it exactly happened at 5 PM అని అంటున్నాడు. Person 2 కూడా ఈస్ టెల్లింగ్ దట్ robbery happened exactly at 12:30 PM. I saw with my eyes. Who is the thief? Come on, students. Person 2 liar, person 1 liar. Why? What are the reasons? Okay, Amulya. Sunaina ma'am will also take classes. Whenever she is free, she will also take classes. Yes, person 2 is lying or person 1 is lying. Which is correct? Person 2, person 2, person 2. See, students, we have a water droplet like this, right? So light is coming. దీని కింద ఇంకొక వాటర్ డ్రాప్లెట్ ఉంది, దీని కింద ఇంకొక వాటర్ డ్రాప్లెట్ ఉంది. నేను జస్ట్ 2 కలర్స్ డ్రా చేస్తున్నాను ఇప్పుడు ప్రస్తుతానికి అయితే. there will be many colors, as you know. right? So this is the human eye. Right students, so ఇక్కడ పైన వాటర్ డ్రాప్ల నుండి ఈ మన బ్లూ లైట్ రే ఉంది కదా, ఇది వచ్చి మన పైన మన ఐలోకి వెళ్ళిపోతుంది, రైట్? సో ఎట్ ద సేమ్ టైం ఇంకొక కలర్ ఎక్కడ నుండి వస్తుంది, ఇంకొక కలర్ కింద వాటర్ డ్రాప్ల నుండి వస్తుంది, కింద వాటర్ డ్రాప్ల నుండి ఉన్న గ్రీన్ కలర్ వచ్చేసి ఈ ఐలోకి వెళ్ళిపోతుంది, రైట్? సో అలా మనం ఇంకా కిందికి ఇలా బెండ్ అవుతే ఈ గ్రీన్ లైట్ కూడా మన ఐలోకి వెళ్తుంది. మనం పైకి వెళ్తే ఒకవేళ ఇంకా వీటి దగ్గర ఇంకా వేరే వేరే కలర్స్ ఉంటాయి కదా, అవన్నీ వెళ్తూ ఉంటాయి ఒకటి వెనకాల ఒకటి, రైట్? సో వన్ ఆఫ్టర్ ది అదర్ ఆల్ ద కలర్స్ విల్ గెట్ ఇన్ టు యువర్ ఐ, right? So this is how the phenomenon is, but this thing is happening when, at what time is this happening? See over here mana light ray anedi first sun nundi originate ayindi, right? So sun anedi mana venakala undi, right? So mana venakala sunlight undi, right? So ee sunlight nundi vachina light ray ne ee light ray, right? Mana sunlight nundi vachina light ray ne ee light ray, sunlight nundi vachina light ray ne this other light ray, this is also coming from the sun, right? So you see, to see a rainbow, manam rainbow ni chudalante mana sun anedi mana venakala undali, right? And the water droplet should be in front of us, right? Mana front lo venakala unde light rays vachi, right? They will come and hit the water droplets, right? Partial internal reflection will happen, dispersion will continue to happen, and that refracted light rays, dispersed light rays will now enter into our eye, and you will see the colorful rainbow in front of you, right? So to see a rainbow, students, you have to face in the opposite direction of the sun. To see a rainbow, you have to face in the opposite direction of the sun, right? And also you will notice that ఈ ఇన్కమింగ్ ఇన్సిడెంట్ లైట్ రే ఉంది కదా, ఇన్కమింగ్ ఇన్సిడెంట్ లైట్ రేకి ఇంకా మన రిఫ్రాక్టెడ్ లైట్ రేస్ ఉన్నాయి కదా, పార్షియల్ ఇంటర్నల్ రిఫ్రాక్టెడ్ లైట్ రేస్, దీనికి యాంగిల్స్ ఉంటాయి, రైట్? సో రెడ్ లైట్ విల్ కమ్ ఎట్ ద టాప్, రైట్? అండ్ వైలెట్ లైట్ విల్ కమ్ ఎట్ ద బాటమ్, రైట్? రెడ్ లైట్ విల్ కమ్ ఎట్ ద టాప్, వైలెట్ లైట్ విల్ కమ్ ఎట్ ద బాటమ్, రైట్? అండ్ దెన్ యూ విల్ నోటిస్ that the angles will be from 40 degrees to 42 degrees. This angle 40 degrees and this angle is 42 degrees, right? So between the incident light ray, right, and the rainbow refracted light rays ki angle varantil majhilo angle untayi kada, so it will be in between 40 to 42 degrees ante, so the light rays will shift in that direction, right? So at an angle of 40 to 42 degrees the rainbow will be formed with respect to the incoming light ray, right? For every other colors as well, this is same for every other colors, 40 to 42. మిగతా కలర్స్ అన్ని మధ్యలో ఉంటాయి. ఒకవేళ ఇది టాప్ ది రెడ్ అనుకోని కిందది వైలెట్ అనుకుంటే మిగతా అన్ని కలర్స్ వైలెట్, ఇండిగో, గ్రీన్, బ్లూ, గ్రీన్, ఆరెంజ్ అన్ని 40 to 42 డిగ్రీస్, ఈ 2 డిగ్రీస్లోనే మిగతా అన్ని కలర్స్ కవర్ అయిపోయి ఉంటాయి, రైట్? సో దిస్ ఇస్ అన్ ఎగ్జాంపుల్ ఆఫ్ ద ప్రైమరీ రెయిన్బో ఫార్మేషన్. Sometimes in the sky you will be seeing double rainbow. ఒక రెయిన్బో పైన ఇంకొక రెయిన్బో ఫామ్ అవుతుంది. That double rainbow is because of the secondary rainbow formation. Okay, so over here the robbery, at which time the robbery might have happened. See, you can see that rainbow is formed, right? ఒకవేళ 12 pm అనుకోండి, 12 pm కి సన్ ఎక్కడ ఉంటుంది స్టూడెంట్స్? 12 pm కి సన్ ఎక్కడ ఉంటుంది? మన నెత్తి పైన ఉంటుంది. If we are here, right, sun is at our top. We have seen that rainbow will be forming in the opposite direction of the sun. అంటే మన rainbow అనేది మన like it should be forming on the land. But will rainbow form on the land? It is not possible. It will only be forming in the region in the air wherever the water droplets are there, right? So obviously in the noon there is no chance of rainbow formation, right? So if you'd see person 1, he says that the robbery happened at 5 pm. 5 pm ante mana sun emo ekkada untundi, right? And rainbow, there is a chance that rainbow can be forming in front of us, right? So even in this case, as you can see, it is formed, right? So it is this case, that is during 5 pm the robbery might have happened. Okay, so option A is correct and person 2 is the thief, right? So one more question I want you to ask, that all the time you will notice that a very half rainbow or a partial rainbow will be formed, right? Is there any possibility for a full rainbow to be formed? Is there any possibility for a full rainbow to be formed? Yes, there is a possibility for a full rainbow to be formed as well. So I will show you. ఇది మన హాఫ్ రెయిన్బో కదా, సో దేర్ ఆర్ పాసిబిలిటీస్ వేర్ యూ గెట్ అ ఫుల్ కంప్లీట్ సర్కిల్. ఏ కేసులో వస్తుందంటే, ఇఫ్ యూ ఆర్ టేకింగ్ అన్ ఏరోప్లేన్ అండ్ యూ ఆర్ లైక్ గోయింగ్ టు అప్ అబవ్ ద స్కై, రైట్? అక్కడ నుండి చూస్తే మన కింద అంతా వాటర్ పార్టికల్స్ ఉంటాయి, ఎందుకంటే మన కింద ల్యాండ్ ఉంది. ఆబ్వియస్లీ ఆ ల్యాండ్ కి మనకి మధ్యలో దెర్ ఆర్ స్టిల్ సమ్ వాటర్ డ్రాప్లెట్స్, రైట్? ఇఫ్ సన్ ఇస్ ఎట్ ద టాప్, ఇన్ దాట్ కేస్ యూ కెన్ స్టిల్ సీ అ రెయిన్బో జస్ట్ బిలో యూ, రైట్? ఎందుకంటే ఆ కేసులో ల్యాండ్ ఉండదు కదా, మన కింద డైరెక్ట్గా ల్యాండ్ ఉండదు, దెర్ ఆర్ వాటర్ డ్రాప్లెట్స్ కదా. ఈ వాటర్ డ్రాప్లెట్స్ కూడా కన్సిడరబుల్ క్వాంటిటీలో ఉన్నాయి, దే ఆర్ ఆల్రెడీ ఎట్ అ లార్జ్ క్వాంటిటీ. ఆ లార్జ్ క్వాంటిటీ నుండి లైట్ విల్ గెట్ రిఫ్లెక్టెడ్ బ్యాక్ అండ్ యూ విల్ బి గెటింగ్ అ రెయిన్బో సర్కిల్, Okay, now here we have a double rainbow formation. How do you get a double rainbow formation, students? See, first of all, in the first case where we talked about the primary rainbow formation, ikkada manaki light rays anedi ee paina surface ki tagili ee direction lo bend ayyayi, right? So in the same way, there can be a light ray that is coming from the top and it can be hitting the rainbow from bottom surface ki tagili ila elli ikkada nundi reflect ayi ila kuda ellochu kada, right? This is also a possibility, right? So the secondary formation will be happening because of that. Okay, so you see, students, see our primary rainbow where red color is at the top, right? So this happened because this is your water droplet, right? It is hitting the top surface and then the light rays are splitting like this, right? Red light ray, violet light ray got split like this, right? And then red light ray came out like that and violet light ray came out like this, right? So the colors, so you have to remember the colors here. In this case, in the primary case, the red will be at the top, at the bottom, and violet will be at the top. And for this also, red will be at the bottom and violet will be at the top, right? So kinda droplet lo unna violet light ray anedi paiki vachi mana eye loki veltundi, right? Paina droplet nundi vachina red light ray vachi mana eye ki veltundi. Eye ki vellinappudu paina droplet nundi red light vachindi, kinda droplet nundi violet vachindi, right? If you will trace this light rays back, so you will notice that your rainbow will be in such a way that the top color will be red and the lower color will be violet. Right now, for a secondary rainbow formation, you see this is this water droplet, right? Now from this water droplet, the light ray is coming from bottom. It is hitting it. Red light ray ila ellindi, malli itla ellindi, malli itla ellindi. Ippudu red light ray anedi paiki vachesindi, right? Violet light ray anedi first light ray nundi violet light ray anedi kindiki vachesindi. Malli same dan kinda unna water droplet consider cheskundam, right? So red ila ellindi, ila ellindi, ila ellindi, ila ellindi, right? So you see again the red is at the top and violet is at the bottom, right? Now you see here is our human eye, right? ఇప్పుడు ఈ హ్యూమన్ ఐకి అన్ని కలర్స్ వెళ్ళిపోవు కదా, పైన డ్రాప్లో నుండి ఒక కలర్ వెళ్తుంది, పైన డ్రాప్లో నుండి ఏమొచ్చింది, వైలెట్ వచ్చింది, రైట్? ఇప్పుడు మనం ఐ పొజిషన్ చేంజ్ చేయట్లేదు, ఐ ఎక్కడ ఉందో అక్కడే ఉంది. అక్కడే ఉన్నప్పుడు కింద వాటర్ డ్రాప్లెట్ నుండి కూడా ఒక లైట్ రే పైకి వెళ్తుంది కదా, దాని నుండి వచ్చిన వైలెట్ లైట్ రే అది మనకన్నా కిందికి వెళ్ళిపోయింది, మన మూతికి తగిలింది లేదంటే మన నోస్కి తగిలింది, ఇట్ వెంట్ అ లిటిల్ డౌన్. ఒకవేళ మనం బెండ్ అవుతే అప్పుడు అది మనకి వెళ్తుంది లోపలికి. బట్ వేర్ ఎవర్ యువర్ ఐస్ ఆర్ ఫిక్స్డ్ ఇనిషియలీ, ఫ్రమ్ ద ఫస్ట్ డ్రాప్ వైలెట్ వెంట్, from the second drop red went, right? So from first drop violet అంటే పై నుండి violet వచ్చింది, కింద నుండి రెడ్ వచ్చింది, కాబట్టి మనకి పైన violet కలర్ కనిపిస్తుంది, కింద రెడ్ కలర్ కనిపిస్తుంది. If you will trace this light rays back. Okay students, now the very important point is, okay, so depending on which surface of the sphere the light rays are hitting, one you will be getting a primary rainbow will be at the bottom and the secondary rainbow will be at the top. This is your secondary rainbow. This is your secondary rainbow. Now look at these rainbows carefully, students. Look at these rainbows carefully. Which of these rainbows is dark and which of these rainbows is light? Which one is light? Which rainbow is light? One or two? Double bow is light or primary bow is light? Even here also you can see. Obviously the colors are flipped. Top one light unda, kinda one light unda. You can see the bottom one is dark, but the top one is light. Why? Why is the top one light? The top one is light. The top one is light because you see there are here light rays got refracted and dispersed, right? మళ్ళీ ఇక్కడ ఏమైంది, ఇక్కడ partial internal reflection అయింది, మళ్ళీ ఇక్కడికి వచ్చిన తర్వాత మళ్ళీ partial internal reflection అయింది, then the light rays got refracted and then they are coming out. If you look at the primary bow, here refraction and dispersion happened and here partial internal reflection happened and then here refraction and dispersion again, right? You see in the primary rainbow there is only one partial internal reflection. In the secondary bow there are two partial internal reflection. Now what will happen because of that? Whenever there is a partial internal reflection, I told you that there will be still some percentage of light ray that will keep going like that. Some 20% అనే ఎనర్జీ మాత్రమే వేస్ట్ అయింది, బయటకు వచ్చేసింది. కానీ ఇక్కడ ఆల్రెడీ కొంచెం లైట్ రే వెళ్ళిపోయింది, 20% ఇక్కడ పోయింది, మళ్ళీ ఇక్కడ మళ్ళీ 20% పోయింది, బికాస్ నాట్ టోటల్ ఇంటర్నల్ రిఫ్లెక్షన్ అవ్వట్లేదు కదా, పార్షియల్ మాత్రమే ఇట్ ఈస్ గెటింగ్ రిఫ్లెక్టెడ్ బ్యాక్, right? Some percentage of the light rays are still getting refracted and they are going out, they are spreading in the atmosphere, they are going into vein. Okay, so the leftover portion over here will just be 60%. ikkada 80% of light is coming back, right? So you see, because of the percentage of light is getting reduced, the intensity of the light will also get reduced, the strength of the light will also get reduced. That is why in a double rainbow case, right, the secondary rainbow will look very less in brightness. Okay, students, see here you are, and this is the drop rate. Here you see the secondary rainbow formation. Light rays కింది నుండి వచ్చి ఇక్కడ ఇక్కడ పార్షియల్ రిఫ్రాక్షన్, ఇక్కడ పార్షియల్ రిఫ్రాక్షన్ ఇలా వచ్చింది, రైట్. పైన రెడ్ వచ్చింది, కింద వైలెట్ వచ్చింది, రైట్. మనకి రెయిన్బో నుండి వచ్చిన కలర్స్ లో పైన రెడ్ ఉంటుంది, కింద వైలెట్ ఉంటుంది, కానీ మనకి కనిపించేటప్పుడు పైన వైలెట్ కనిపిస్తుంది, కింద రెడ్ కనిపిస్తుంది. ఓకే, సి లుక్ ఎట్ ఫర్ ద సెకండ్ డ్రాప్ ఆల్సో. లైట్ రేస్ కేమ్ లైక్ దిస్. పైన నుండి రెడ్ వస్తుంది, కింది నుండి వైలెట్ వెళ్ళిపోతుంది. ఈ కింది నుండి వచ్చిన వైలెట్ కిందికి వెళ్ళిపోతుంది. మన ఐ ఒకవేళ ఇక్కడ కింద ఎక్కడైనా పెడితే ఆ వైలెట్ అనేది మన ఐలోకి వెళ్తుంది, రైట్. సో చూడండి ఎవ్రీవన్. సో ఫ్రమ్ ద సెకండ్ డ్రాప్ ద రెడ్ ఈస్ కమింగ్, దిస్ రెడ్ ఈస్ కమింగ్, అండ్ పైన డ్రాప్ నుండి వచ్చిన వైలెట్ లైట్ రే, ఇంకా కింద డ్రాప్ నుండి వచ్చిన రెడ్ లైట్ రే, ఇవి ఇలా వచ్చి కింద నుండి రెడ్ వస్తుంది, పై నుండి వైలెట్ వస్తుంది. సో దట్ ఈస్ వై వెన్ యూ ఆర్ లుకింగ్ ఎట్ ఇట్, సో యూ విల్ నోటిస్ దట్ వైలెట్ ఈస్ అట్ ద టాప్ అండ్ రెడ్ ఈస్ అట్ ద బాటమ్, బికాస్ దట్ వైలెట్ కలర్ ఈస్ కమింగ్ ఫ్రమ్ ద లోవర్ కలర్ ఆఫ్ ద పైన డ్రాప్, బికాస్ పైన డ్రాప్ నుండి వచ్చిన రెడ్ లైట్ రే అనేది ఆ డైరెక్షన్ వెళ్ళిపోయింది కాబట్టి, right, that cannot enter into your eye, right. So there will still be a switch in colors when compared to the lights that are coming from there and coming from here. Okay, whenever you draw a normal rainbow formation, you are drawing the primary rainbow formation. Okay, for primary rainbow formation, remember these colors. This is the primary rainbow case, right, where the light ray is coming and getting refracted from the top. నుండి రిఫ్రాక్ట్ అయినప్పుడు పైన వైలెట్ ఉంటుంది, కింద రెడ్ ఉంటుంది, రైట్. పైన వైలెట్ ఉంటుంది, కింద రెడ్ ఉంటుంది. బట్ when it is entering into your eye, పైన డ్రాప్ల నుండి వచ్చిన రెడ్ లైట్ అనేది మన ఐలోకి వెళ్తుంది. ఇక్కడ చూడండి దీస్ కలర్స్, రైట్. కింద డ్రాప్ల నుండి వచ్చిన వైలెట్ లైట్ అనేది ఇట్ విల్ గో ఇంటు యువర్ ఐ, రైట్. అండ్ ఫర్ ప్రైమరీ rainbow formation you will see red at the top and violet at the bottom. Understood, students? Violet at the bottom. For primary, violet at the top. Red at the bottom. Okay, and you will also see that the angle made by the secondary rainbow, ఈ లైట్ ఇన్కమింగ్ లైట్ రే ఉంది కదా, ఈ ఇన్కమింగ్ లైట్ రేకి ఈ రెయిన్బో లైట్స్ ఉన్నాయి కదా, సో దీస్ యాంగిల్స్ విల్ బి ఇన్ బిట్వీన్ 50 to 52 degrees. ఫర్ ప్రైమరీ రెయిన్బో వీ హ్యావ్ సీన్ ది యాంగిల్స్. ఫర్ ది ప్రైమరీ రెయిన్బో ఈ ఇన్సిడెంట్ యాంగిల్ నుండి ఈ వైలెట్ లైట్కి యాంగిల్ ఎంత ఉంది, దిస్ విల్ బి 40 degrees, రైట్. సిమిలర్లీ ఫ్రమ్ దిస్ ఇన్సిడెంట్ లైట్ రే ఈ రెడ్ లైట్కి యాంగిల్ ఎంత ఉంటుంది, ఇది 42 degrees ఉంటుంది, right. So the rainbow is forming at an angle of 40 degrees. Minimum angle is 40 degrees with respect to the incoming sunlight. Okay, ఆ లైట్ రే అలా వస్తే అక్కడ నుండి 40 degrees కిందికి ఇలా మనకి రెయిన్బో అనేది ఫామ్ అవుతుంది. That is the meaning of it, right. And all the other colors will be in these angles only. Okay, during explaining I have told that over there the color is different, but this is the correct explanation. Right, for a secondary rainbow formation, the red light will be at an angle of 50 degrees from the incoming light ray, and the violet light will get refracted, okay, or partially internally reflected at an angle of 52 degrees. Understood, students, this particular concept, primary rainbow formation and secondary rainbow formation, this is very important. Write down these angles, students. Mention these angles in your notebook. Put the colors correctly. School any గంటలకు students? When do you have school? Because this is my first class or taking in the early morning, so I don't know which time you have school. Hello Teja, welcome to the session. College? Jilla, you're going to college? 9 a.m. Maybe your schools are so near to you. You can quickly reach your school in half an hour, maybe. Good students. Good that your students are still in school. It is good to have those memories when you're in school already. Because once you grow up, once you come out of the school, you can't get back to school again. Past is past. But school life is the best life. Use your school life, school time very well, students. Okay, good, Yash. Good morning, Jyoti. Welcome to the session. Okay, so you see over here we have a primary rainbow and then we have a secondary rainbow, right? So primary rainbow formation will happen with only with one PIR. Secondary rainbow will happen with two PIRs. So because of that, the strength of the light will get reduced. You miss your school 10th. You've already finished your school 10th, Chiki. You can't get your friends back. Like even if you'll get your friends back after you finish your school, so they don't have the same behavior. So the fun that you will do in your school, so all of them are like so different. You'll only get if you were having this chance again to get back to school with using a time machine. Okay, once you are in the future. Oh, what do we see? We see a full rainbow here. Look at this, students. We have a sky, right? And then this is the full rainbow formation. నార్మల్లీ మనం ల్యాండ్ పైన ఉన్నప్పుడు మనకి ఫుల్ సర్కిల్ కనిపించదు ఎందుకంటే హాఫ్ సర్కిల్ ఫామ్ అవుతుంది దాని తర్వాత కింద ఇంకా వాటర్ డ్రాప్లెట్స్ లేవు కదా సో యూ డోంట్ ఫైండ్ దీస్ వాటర్ డ్రాప్లెట్స్ ఇన్ ద గ్రౌండ్ అండ్ దెన్ ఎవ్రీథింగ్ దట్ యూ సీ beneath you is ground, right? So if you're taking an aeroplane and then you're going up in the sky, right? So from there you will be able to see a rainbow formation like this. Okay, yeah, Gangaraju, I know the feeling. Okay, so with respect to the light ray that is coming towards the water droplet, with respect to the light ray that is coming from the sun, or if you are drawing that same light ray that is passing through the center of this circle, you're passing that same light ray. See, initially the light ray was coming from the sun like this, right? So the angle between that and this is 40 degrees, and the angle between that light ray and this blue light ray is 42 degrees. Now students, do not get confused. So you can see that here the rainbow, here it is with red, right? Indaka kuda like when I told it with respect to this particular color. Okay, with respect to red, the incoming light ray will make 40 degrees. What did I mean? ఇక్కడ ఏమని చెప్పాను in the primary rainbow formation. This is the primary rainbow formation. Here is the primary rainbow formation, right? And here the violet is at the top, right? Here you see the red is at the bottom, right? And you see this angle is 42 degrees. Okay, this angle is 42 degrees, right? So but this is with respect to the colors that are coming from the droplets. If you look at the colors that are coming from the water droplets, the red will be at the bottom, right? But with respect to this rainbow formation, see this is the red color kada manam chustunam with respect to that, it will be making angle with the red, that much angle. Okay, it depends on what are you considering it, right? So normally if you are just like considering with respect to the sunlight, okay, if you are considering the angle with respect to the sunlight that is incoming, okay, the red light will be at an angle of 42 degrees and this is unchanged, right? And with respect to the same sunlight coming, the angle that the violet light is getting partially internally reflected, right, that angle is 40 degrees, right? But this color is the color that you will see when the light rays are coming from the lower droplet into your eye, okay, and when you are like tracing that light rays back, okay. So in that case you will be noticing the colors like this, right? So you can see this incoming sunlight and this this imaginary line that is going through the center of this circle, these are parallel, okay. If they are parallel, right, if they are parallel, you can see these two angles are, this angle is a transversal, right, and these are alternate angles, and these angles will be equal along the transversal, right? So violet, it is 40 degrees and red, it is 42 degrees, right? So if you are taking a flight and going up in the sky, right, so from there, because you are already at a height like this, somewhere over here, right, so there are still some water molecules beneath you, right? So mana sunlight anedi painundi ekkadundo vastundi, right? So ila painundi vachi mana kindi nundi ila veltundi sunlight, mana kindi nundi velli ikkada manaki water droplets ki tagili, then the light rays will come and reach your eye from all these directions. If you are changing your flight location, ఇక్కడ నుండి ఇక్కడికి వెళ్ళిపోయినప్పుడు ఏమవుతుంది, ఇక్కడ ఇంకా వేరే వాటర్ డ్రాప్లెట్స్ ఉంటాయి కదా, అక్కడ నుండి వచ్చిన లైట్ రేస్ నుండి మనకి కనిపిస్తుంది అక్కడ. సో దేర్ ఇస్ అనదర్ రెయిన్బో లైక్ దిస్, రైట్? బట్ నార్మలీ వెన్ యూ ఆర్ ఎట్ ఎ లొకేషన్ యూ కెనాట్ సీ ఆల్ దోస్ మల్టిపుల్ రెయిన్బోస్. విత్ రెస్పెక్ట్ టు వన్ పొజిషన్ ఆఫ్ యోర్స్ యూ కెన్ ఓన్లీ సీ వన్ రెయిన్బో. మనం పొజిషన్ చేంజ్ చేసినప్పుడు అక్కడ ఇంకొక రెయిన్బో వస్తుంది, ఈ ఫస్ట్ రెయిన్బో మాయమైపోతుంది. అది మాయం ఎందుకు అయిపోతుంది అంటే ఆ లైట్ రేస్ అనేవి మన ఐస్లోకి వెళ్ళవు, ఎందుకంటే మన ఐ లొకేషన్ అనేది చేంజ్ అయిపోయింది కాబట్టి, అంతే. Right? So all the colors that you will see only when the light is entering into your eye, right? Hence the name human eye and the colorful world. Wherever you have your human eye, only from there you can see the world colorful, right? The light rays that are coming from different parts that are not entering into your eye, they are not reaching your eye, so you cannot see the colors from those, right? So there is a relation between the human eye and the world that you see around you. Now there are more rainbow formations as well, right? So like you can see there is white rainbow, there is fire rainbow. Just a second, students.
Maybe I don't understand this. You're changing, I can't stand it. My heart can't take this damage. In the way I feel, can't stand it. Maybe I don't understand.
Yes, students. I hope you can see me again. Yes, students. So there are more other different forms of rainbow formations as well. Like for example, we have a white rainbow. White rainbow is usually happens, right? So whenever you have a fog around you, right? Instead of water droplets, manaki thick fog snow like sort of untundi kada. Like in India, like mostly you have fog, right? So not a complete snow form, right? But yet you will see fog, right? So that thick, moist, dense particles in your atmosphere, right? So it is all completely because of icy water and mist, right? So now manaki rainbow lo water droplet unde, right? So water is having a different refractive index and fog is having a different refractive index, right? So over there different colors got refracted by a greater degree, okay? But the amount of dispersion and it will differ from medium to medium, right? So water is different, similarly prism is different, so over there is a different quality of dispersion, right? Similarly fog is also different, right? So it and this matters a lot. What is the material nature of an object, okay, in which the dispersion is happening, right? And the refractive index of that object in which the dispersion is happening, right? Fog lo different refraction dispersion ఉంటుంది మనకి water droplet different ఉంటుంది కాబట్టి the rainbow formation in a white rainbow will also be different, okay? See, there are colors here, but all these colors are of very reduced quantity, or otherwise because of the presence of the fog you will not be able to see all those colors properly, right? So closely we know that when all the colors are getting mixed up according to the Newton disk experiment, so what Newton has done is he has taken a disk and he divided that disk into 7 different constituents, right? So he divided it into 7 different parts, right? And then all the colors, violet, indigo, blue, green, yellow, orange, red, all the colors are filled in this, right? And now what he did is he attached this disk to a motor. He attached this to a motor, right? And now he started to rotate it, right? Now this disk, it started to rotate, right? Initially it was divided and it was separately colored with these colors, right? Now when he rotated it, after a little while, what did he see? What do you see, students, after a little while? This is going with a very fast speed, right? Here the speed is 0 rpm, 0 rotations per minute. Here it is 100 rpm, 100 rotations per minute, right? So in this case now you will only see one color, that is white, right? ఇంతకు ముందు 7 different colors separate అయి ఉన్నా కూడా, so now in this case you will only see one color, that is white color. More wavelength red will have, okay? And the reason why red has more wavelength, it is nothing but it is the beauty of this nature, right? So it just happened like that, red is having this much wavelength, and what we just did is we just measured that wavelength and then we gave it a name, that is red color. ఆ రెడ్ కలర్ లైట్ రేని మనం రెడ్ అనే నేమ్ చేయాలని ఉండకపోవచ్చు. దట్ రెడ్ కలర్ ని వి కుడ్ హావ్ గివెన్ అదర్ నేమ్ లైక్ yellow also, right? But scientists or the researchers or the primitive men, okay, initially they just named it like that, right? So your mother called you Chiki or Amu, and then after that everybody kept calling you Chiki and Amu, right? If somebody would have called you with another name like Parvati, right, then you would have been called with Parvati, right? So it's just a name that is given to it, right? And red light, it just happened that that particular light, red light, is whatever is having red wavelength is named red. If it was named violet, then violet would have had a greater wavelength. Blue is having the shortest wavelength, blue is having higher frequency, red is having lower frequency, right, and longer wavelength. So now you see, students, white light. So white light, so when you have all the 7 colors, when you will mix them, right, so then you will be getting this white light, right? And this white light is present like this, right? So this white light, it is just a combination of all those 7 different colors, right? So now here, this particular fog formation over here, that whatever we are seeing, right, it is a white rainbow, right? So this white rainbow is not, it is looking white in color because there is some splitting there is some dispersion that has happened there, right? But because of the fog having a different refractive index, right, the dispersion is not that much visible, right? So hence you will only see the rainbow in a white color bow sort of, right? Arrow and bow we know, right? So you will still see a bow there, right? But if you talk about a fire rainbow, in fire rainbow you won't be able to see the bow, right? But still you see at the periphery of this particular clouds, right, you will see these colors. Okay, you don't see a clear bow, but these colors are randomly spread over there, right? So maybe because of the surface of the clouds, or that maybe there is a icy formation, like very closely. See, normally when you have water droplets, they are in the saturated state, water vapor, right? So if even by a little degree, if the clouds are heated, what will happen? All clouds will get converted into water droplets, right? And all that water in the form of air, in the form of rain, will fall down, right? But the temperature over there, nobody is disturbing that temperature, right? It is just happening by nature naturally, right? So naturally, whenever these clouds will experience a temperature rise, right? So in that case, you will be getting rain, right? And the temperature rises obviously because of the presence of the temperature and presence of the sun, right? So maybe at that particular cloud, right? So that cloud is having some different medium, right? Now maybe at the periphery, right? Because of some unexpected circumstance, right? So a circumstance valla clouds lo unna periphery lo unna region lo unna water molecules untayi kada, they are in a different phase now. Maybe they are close to ice, maybe they are close to water, right? So maybe they are close to some different things, right? There are some different percentages involved in that, right? And then now it is a different phase, right? Now that is able to disperse light by a greater degree, right? And because of that dispersion, you see this fire rainbow formation, right? So fire rainbow formation is formed by these icy clouds, right? So which are at higher altitudes, right? So which will be normally floating at higher altitudes, and at the peripheral of that, you will be noticing this fire rainbow, right? So though the bow formation is not really formed, because there are this splitting of colors, and we call like one of the phenomenon, మనకి ఎప్పుడైతే స్ప్లిట్టింగ్ ఆఫ్ కలర్స్ ఉంటాయో, మరి అది కూడా ఒకవేళ న్యాచురల్గా అవుతే దాన్ని మనం రెయిన్బో అంటాం కదా. సో జస్ట్ లైక్ దట్ వీ గేవ్ దట్ నేమ్ రెయిన్బో, బట్ ఇస్ ద ఫైర్ రెయిన్బో, right? Similarly, we have a moon bow. See students, moon bow will happen in rural areas. In rural areas where the street lights are not there, street lights are missing, right? So where that surroundings is completely dark, right? So alanti regions lo, if you'll go to the farm side, go to the farm and then like stay there one night, right? So if obviously there are some water droplets in the atmosphere, right, because of the cold weather conditions, right? Because there are trees around it, so transpiration of water will happen. ట్రీస్ ఎక్కడైతే ఉంటే అక్కడ ట్రాన్స్పిరేషన్ అవుతుంది. అందుకే మనం నార్మల్గా ఒక ప్లేస్ నుండి ఇంకో ప్లేస్కి నైట్ ట్రావెల్ రోడ్ పైన చేసామనుకోండి, ఎక్కడైతే మనకి ట్రీస్ ఉంటాయో ఆ ప్లేస్లో మనకి చాలా చల్లగా అనిపిస్తుంది, రైట్? వన్స్ ద ట్రీస్ ఆర్ గాన్, సో యూ విల్ ఫీల్ ద వార్మ్త్, right? That is because of the transpiration. So there are water molecules around that region wherever the trees are, and when you are moving in that region, our water droplets vachi మన skin ki tagli, so we will feel cold, right? So now this particular moon bow, this is forming, as the name suggests, it is coming from moon. The light is coming from moon, not from the sun. See, when we talk about rainbow, there are rainwater molecules, right? And then there is sun that is behind us, right? Mana enakal nundi that sunlight is coming, it is hitting the droplets, and then it is entering into your eye, you get a rainbow, right? For a moon bow, the light is coming from the moon. Already the weather or the surroundings, the environment is completely dark, right? And then there are small little water droplets there, right? Anta dark unnappudu koncham light pettina kuda you will be able to see that light, right? Now that light ekkada nundi ostundi, mana moon nundi ostundi, moon నుండి వైట్ లైట్ వస్తుంది, రైట్? ఆ వైట్ లైట్ వల్ల మన చుట్టుపక్కల సరౌండింగ్స్ అన్ని లిట్ అయ్యాయి. యూ కెన్ స్టిల్ సీ ద థింగ్స్ దట్ ఆర్ అరౌండ్ యూ, రైట్? నౌ దట్ వైట్ లైట్, ఇఫ్ ఇట్ ఈస్ ఎంటరింగ్ ఇంటూ అ వాటర్ డ్రాప్లెట్, now from that water droplet, the dispersion of light will happen, partial internal reflection of that light will happen, again refraction will happen, right? But only one time, right? Maybe a primary rainbow or a secondary rainbow, right? But it is obviously it is all dark, right? So primary rainbow కనిపించడానికి చాలా difficult గా అనిపిస్తుంది, right? If it is even a little early morning or something like that, in that case you can also see a secondary rainbow about it, right? So this moonbow is formed because of the moonlight, right? And the colors are not that much bright when compared to the rainbow, the natural rainbow that we normally see, generally see around us. Yes, students. So these are the different forms of rainbows. You can write down in your notebook. White rainbow, fire rainbow, moonbow, and the general rainbow. And now, how does light from the stars differ from the moonlight? How does the light from the stars differ from the moonlight? What are stars? Now, what is moonlight? Me, I'm from BCIL. Okay, now, see students, starlight. Starlight is coming from the stars. Now, what are stars? What is the closest star that we have in our daylight? What is the closest star to the earth? What is the closest star to the earth? This is earth. What is the closest star to the earth? Don't tell serious. Come on, who gives me this answer, students? Okay, it is sun. Right, sun is the closest star. See students, stars, how do they give you light? How do they give you light? See, normally stars, generally sun, right, it is actually filled completely with hydrogen atoms, right? Sun is filled with hydrogen atoms, right? And sun has its gravity. There is a gravitational pull between any two objects in this universe. Between any two objects in this universe, if you will consider, according to the universal law of gravitation, right, every object attracts every other object, right, with a force that is directly proportional to the product of these two objects. Every object attracts every other object with a force that is exactly equal to the product of the masses of these two objects, and that force, every object attracts every other object with a force which is inversely proportional to the distance square of them, the distance square between those two objects, right? F is equals to gmm by r square. That is the general formula of the gravitational pull between any two objects in this universe. That is the universal law of gravitation, right? So now, because of that force, there is a gravitational pull between any objects, right? Which means that gravitational pull అనేది ఒక ఆబ్జెక్ట్ కి ఇంకొక ఆబ్జెక్ట్ కి మాత్రమే ఉండదు. It will also be there for that same object. Gravitational pull of an object for the same object. అంటే sun ఉంది, right? So you have sun, right? Sun center లో there is a gravitational pull, right? And this sun pull will happen from all the circumference, the surface, right? All the things that are present on the surface of the sun will also get pulled towards the surface, not just some other object that is earth somewhere here, right? And it is because of the gravitational pull that earth is around is going around this particular sun. Right? This is the general logic, right? So now this pull, because of this pull, I told you that sun is completely filled with hydrogen atoms, right? So under its own gravitational pull, what will happen is sun will try to pull all the hydrogen atoms together. It will try to pull all the hydrogen atoms together, right? It will pull them together, and finally what will happen, it will bring it much closer, all because of its own gravity. Under its own gravity, under sun's own gravity, all the hydrogen atoms will come together, they will get fused. They will get fused completely. One hydrogen atom will get into another hydrogen atom, right? And then nuclear fusion will happen, right? When two atoms are fused, right, there is an enormous amount of energy that is released, right? There is an enormous amount of energy that is released. A supernova is created, right? That energy, not in the form of a supernova that brings catastrophe. Supernova, or that supernova ante adoka event, okay, which brings a great catastrophe where everything will get disturbed, everything around it, right? But here it will be a very small supernova sort of thing, right, wherein the energy that will get released once this nuclear fusion will happen, right, will be in the form of light and energy, right? When two hydrogen atoms will get fused, you will get a helium atom, right? So now all the atoms here are helium, right? Then these helium atoms will also get fused. Let's go to that story a little later. So now these hydrogen atoms got fused, right? So you get a nuclear fusion. Now whenever there is a fusion, right, there is some energy that is released in the form of light, right? Now that light that is coming from the sun is your starlight. That is your starlight. That is your starlight, right? And any star that you see in the night sky, any star you see in the night sky, like Sirius, right, the light that is coming from that star is again the same light that is coming from the sun. Okay, just like how sun gives its own natural light, in the same way even Sirius, the other star, gives its own natural light, and so does the other stars that are spread in the earth, in the night sky, right? So that light is now entering your body or any object around you, right? And every object that is around you, right, will absorb some quantity of light that is incoming. It will reflect some amount of light and it will refract some amount of light. This concept I told you in the last class also, right? Absorption, reflection and refraction. And I told you that the reason why we see colorful world around us, right, the reason why we see colors around us, it is all because of this white light, right, and the reflected light ray from the object. White light is coming and hitting an object, and it depends on which object it is hitting, right, that different colors will get reflected back. Okay, ఒకవేళ యాపిల్ చూపిస్తాను నీకు, యాపిల్ అనేది రెడ్ లైట్ ని రిఫ్లెక్ట్ చేస్తుంది, మిగతా అన్ని కలర్స్ ని మేబీ ఇట్ ఇస్ అబ్జార్బింగ్ అండ్ మేబీ ఇట్ ఇస్ లెటింగ్ ద లైట్ రే టు కీప్ గోయింగ్ లైక్ దట్, రిఫ్రాక్టెడ్, right? And it depends on which color light ray got reflected back from an object. ఏ ఆబ్జెక్ట్ నుండి ఏ కలర్ లైట్ రే అయితే రిఫ్లెక్ట్ అవుతుందో ఆ లైట్ రే మన కంటి లోపలికి వెళ్ళి, రైట్, మనకి ఆ ఆబ్జెక్ట్ అనేది ఆ కలర్ లో కనిపిస్తుంది. Because our human brains will try to extrapolate those light rays, and wherever they have come, it will mark a point there, and that point is that color. If you see a blue color object, maybe that object is only reflecting blue color light rays, right? So now this starlight is different from moonlight because this moonlight is not a natural light. Moonlight is a reflected light. ఈ సన్లైట్ నుండి ఏదైతే వచ్చిందో, రైట్, ఇప్పుడు మన మూన్ అనేది ఇక్కడ ఉంది, రైట్? నౌ అవర్ మూన్ ఇస్ ఇన్ విచ్ కలర్? Moon is in which color? This is our earth. Moon is in which color, students? Moon is in white color. When do you get white color? When do you get white color? Vibgyor. Whenever these 7 colors will mix, you get a white color. అంటే ఇప్పుడు మన సన్ నుండి వైట్ లైట్ వచ్చింది, సన్ నుండి వైట్ లైట్ వచ్చింది, ఇక్కడ సన్ నుండి వచ్చిన, ఒకవేళ నువ్వు మూన్ పైన నించున్నావు అనుకో, సన్ నుండి వచ్చిన వైట్ లైట్ ఇలా వెళ్తుంది, వెళ్ళిన తర్వాత ఎర్త్కి హిట్ అవుతుంది. మోస్ట్లీ ఎర్త్లో ఉన్న స్కై ఉంటుంది కదా, అట్మాస్ఫియర్ ఉంటుంది కదా, దానికి హిట్ అవుతుంది, రైట్? హిట్ అయిన తర్వాత స్కైలో ఉన్న దెర్ ఆర్ సమ్ మాలిక్యూల్స్, దెర్ ఆర్ సమ్ డస్ట్ పార్టికల్స్, దెర్ ఆర్ సమ్ గ్యాసెస్ అండ్ ఆల్, రైట్? దీస్ ఆల్ గ్యాసెస్, వాట్ ఆర్ దే డూయింగ్ ఇస్ దే ఆర్ అబ్జార్బింగ్ all the other colors. They are absorbing violet, they are absorbing red color, they are absorbing orange, yellow, they are letting the light to pass through them. Anni absorb cheskovu, they will also let the light to keep going like that, pass through them, right? And it is reflecting the colors such as blue, indigo and violet. Okay, mostly maybe blue is getting reflected back, absorbed and scattered back from these atmospheric molecules, right? And that blue color light ray is now reaching your eye when you are on the moon, right? Now that is why you see earth in blue color. And somebody asked the question, why sky is in blue color, right? So sky is in blue color because the atmosphere, the dust or the gases that are present all around you, right? So they are scattering the blue light most. Okay, they are absorbing and re-emitting this blue light, which is having the shortest wavelength, right, in all the possible directions. You know that violet is having the shortest wavelength, but you don't see sky in violet color, because one more reason is there. One more reason is our human eye అనేది ఎలా డిజైన్ అయిందంటే, it is designed in such a way that it is more sensitive towards blue color. Okay, blue color వచ్చి hit చేస్తే we can clearly sense that color, that is blue, and it will give you blue. Okay, human eyes are not that much sensitive towards violet color. Violet color కూడా వచ్చింది అనుకోండి, but we are not able to recognize that color we are not able to recognize that color properly as compared to blue color. Okay, and why can't we recognize? That is how human beings are made. Okay, we can't change that. We have limits to our energies, right? That is why we eat food after we go low in energy, right? Now in the similar way, now this white light is coming and hitting the moon, right? Now this moon will reflect that light, but it is reflecting all the colors equally: violet, indigo, blue, green, yellow, orange, red, all the colors equally, right? And when all these colors are mixing, what color do you get? White, right? And that is how, when you are a person who is standing on the earth, right, and when you are looking at the moon in the night sky, right, so you see moon in white color, because all the colors are hitting the sun, hitting from the sun, it is hitting the moon, and all the colors are equally getting into your eye, right? So this is the difference between moonlight and starlight. Starlight, that white light is directly getting into your eye, right? Moonlight, that white light is going and hitting the moon, and all those 7 colors are equally getting reflected back, and again that same white light is coming into our eye. Okay, the only thing that is not happening is some of the light ray getting absorbed by the moon and getting refracted by the moon. All colors are getting equally reflected back. Okay, students, so with this we will end our session. With this we will end today's session, right? Human eye on the colorful world, right? So we will continue from here in the next session, right? So also it is 7:30. We've had a 2 hours stretch class for today, and that is done, right, students? So Telangana state boards and the derivation that I've shown you properly previously, right? So that derivation is important, right? So we will meet again in the next session, students. We'll meet again in the next session. So I request all of you to go and finish up your work, go fresh up, right? Go to your school, enjoy your school, enjoy your day today. Yes, students, and write your exams very well. Exam very well if you're already having an exam today, right? It's fun to go to school, students. It is so fun to go to school. Don't feel like so lazy going to school and all, right? You will know this once you finish your school. It is common with every person, every student. All right then. So bye, students. Bye, Chiki. Bye, family. Bye, Teja. Bye, Inti, Nihali, Nikhila, Neeraja. Welcome to this session. Yeah, hello. Bye, students. Bye, Amu. So bye, Yash. We'll meet again in the next session. Then thank you so much for joining. That's it for this session. So this is Narayan, physics faculty. So signing off.
Baby, I don't understand this.